Good day. This is Globavasity. I am the producer, Engineer Obisike Okechukwu Elechi, Director Globavasity. I wish to introduce to you this basic mathematics for the families. Buy them, they are very, very interesting. It is good for adults that wish to go to bank or that are finding it difficult to go to bank, because we have numerals so that you can know how to write in figure and in words. We have so many things under this. It is basic mathematics. Those things that you learn that will make you move well in life. I tell you, some people look at mathematics as an abstract. It is not abstract. We have a textbook here, Globavasity, Basic Mathematics Workbook. I call it workbook because it has to do with what is on this DVD VCD, part 1. What we are doing today is the part 1, series A. Then we also have part 1, series B. Please get this for your family. Go through it. It's very extensive. You will discover that inside this very textbook, it is simple to complex. Too many exercises. Every lesson or topic has more than 50 exercises as it is here. So get it for your family and help yourself. Our centers are everywhere all over Port Harcourt. We are the best adult education centers here in Port Harcourt and outside. We have schools all over. We have morning sections, afternoon and evenings. Contact us today. You will not regret it. Chapter 1, I will call it lesson 1. We are to deal with enumeration or counting. We want to count. There's no how you learn your mathematics without knowing your 1, 2, 3. You count and write in figure and in words. But we have to start with this, counting. So you count with me. Raise up your voice, be very audible, and let us read together. This is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. In this case, it means we can now count 1 to 3. 1 to what? 100. Now let's take it again. Let's count again from 1 to 20. Let's take it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Take it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Good. Let's stop there for now. Now we read up to what? 20. We can count up to 20. So the only thing is for you to understand the pattern, the format. If you can read from 1 to what? 20. When we talk about 21, you now write 2 with what? 1. To give you what? 21. Now you look at this other one. 20 what? 22. You write 20 with what? 2. That's 22. In that way it goes. Now let us read this one down to 100. Let's read 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Say 100. 100. So your 100, we write 1 with the double what? 0. So it goes 80. So if you understand we are 10 to 20, from 10 to 100, if I say 70, you now know that 70 is 7 with what? 0. To give me 70. So if I say 71, it will be 1 what? 71. Is it not so? Yes. If I now say 72, it becomes what? 7 and what? 2. To give you what? 72. If I say 85, you now write your 80. Is it not? 80 is like this, is it not so? Yes. So 85 will be 8 with what? 5. To give you what? 85. In that way, we will say that you know how to count from 1 to what? 100. And on your own, before I will forget, in our book, this book here, Globavasity, Basic Mathematics Workbook on DVD, what we are showing today, you discover that all these things are there, the questions, exercises. You have a lot of exercises inside this book, a lot of them, more than 50 per each lesson. So you go through the book, get the book, as you watch, you study on your own and answer so many questions. Let us read from here. From here, this is what? 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. Can you see? So if it is 40, you enter 41, 42, 40, down to 50. If it is 90, this is 91, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. Or 100. Now, if you watch this way, we have 4 here. 4 with 1 will give us what? 14. 24, 34, 44, 54, 64, 74, 84, and what? 94. Let us enter now. As you see, this is 8. Is it not so? Yes. Now, when we go, this is what? 8. 18. Because 8 with 1. 1 with 8 is what? 18. Here, 28. Here, 38. That is 3 with 8 will give us what? 38. 4 with 8. 48. What? 58. This one? 68. This one? 78. This one? 88. And this one? 98. 9 with 8 will give us what? 98. So, let me explain some other ones. Now we can write from 1 to 100. I still want to inform you that we have something like 100, 200, 300, 400, 500, and thereabout. we have, as you can see, 200 will be like this. Is it clear?
Yes, sir.
This is 200. This is what? 300. This is what? 400. This is what? 500. This one is what? 600. Once you see a figure or a digit with what? Double what? Naught. It means 100. And in this case, I will use place value. I will use what? Place value to explain. But let me write this one. 600. This one is what? 700. And we have 8 with double 0 to give us what? 800. And we have 9 with double 0 to give us what? 900. And then we now have 1 with 3 0 to give us what? 1000. I will come to that. So if you have 200, 300, 400, 500, 600, 700, 800, if I want to place something, I will say, okay, let's use place value. In that case, you see like this. Place value. On that place value, look at what I will do, so that you understand the nature. We have what is called 100, tens, and what? Units. This one means unit. Unit or units. And this one is what? Tens. Is it clear?
Yes,
and this one is what? Hundreds. Say what?
Hundreds.
Hundreds. Is it clear?
Yes,
we can also have thousand. That's TH. It becomes what? Thousand, thousand, hundred, tens, and what? Units. If I have 200, it means it will be here. Is it not so? 2 under 100, 0 what? 0. Is it not so? That is what? 200. So if I say 205, 205 will be 2 or what? 5. This 5 is a unit. But if I say 240, it becomes 2 and what? 40. 40 is under tens and not 100. If I say 245, it becomes 200 and what? 45, which is 4, 5. 2, 4 what? 5. 200 and what? 45. From our accounting, we know that this is what? 45. This is 200 and what? 45. This one is what? 205. Now, we have 400, 800, 900. Let's take 1000. If it is 1000, 1 will come here. Is it also?
Yes.
We have 0, 0, 0. This column is called units. This one is called what? Tens. This one is called what? Hundreds. And this one is called what? Thousands. If it is 2000, I will put what? 2 here to give you what? 2000. If it is 7000, I will put what? 7 under 1000 to become what? 7000. So if I say 7020, it will not be 70 because it's not 100. 20 is under tens. I put my 20 here. Is it clear?
Yes,
7,000 and what? 20 and 20. Now if I say 7,220, it will be 7,200 under 100. You put 2. Is it also?
Yes.
And then you put our what? 20. So 7,200 and what? 20. You must understand these place values. It will help us to add and subtract under this numeration.
Yes.
So if I have 2,000, 2,000 is like this, is it not so?
It is.
Therefore, 7,000 will be what? 7000. Is it not so?
It is.
Now, if I have something like this, can you pronounce it? What is it? 10,000. Call it again. 10,000. 10. 1, 2, 3, giving us what? 1,000. Because what? 10,000. So we call it tens of thousand. We also have thousands under hundreds. In that case, it will be what? Hundreds of what? Thousand. In our place value, we have hundreds of thousand. Are you with me?
Yes, sir.
We have tens of thousand, TH. We have tens of thousand, we have thousand, TH. Then we have hundred, tens, and what? Units. So if I have 100,000 as it is, okay, let's say 200,000, I'll put 2 here. You understand now?
Yes,
200,000, and put my 0, 0, 0, 0, 0. So this is what? 200 what? 1,000. This is 1,000. Yeah, 1, 2, 3. 200,000. Or if I say 200 and the what? 50,000. Say it again.
250,000.
You know, 250,000 is a different thing altogether. 250 what? 1,000. That 1,000 is under tens. It becomes 250. Is it not so? 250 before what? 1,000. But if I say 250,500 or 420 or 86, we can now say, or say, let's say 300. 350 what? 1,000. Is it also? This is under 100. If it is 400, say 470 what? 8. This 8 here is under what? Units. This 7 is under what? Tens. This 4 is under what? 100. But something happens. One unique thing is that we use let me see if I can introduce that one very fast. They call it abacus. Say what? Abacus. Abacus is a kind of illustration where I will put something like this, representing that my 100 tens are unit. This is unit, this is tens, 100, 1,000, and tenth of what? 1,000. And then assume I put up something like this. If you see something like this, it means how many there? 2. It means what should be here should be what? 2. If I put, say, nothing here, and come here to put, how many? 1, 2, 3, what? 4. So here becomes what? 4. And if I put 2, okay, 3. 1, 2, what? 3. It means under 1,000 we have what? 3. Is it clear?
Yes.
Then here now, maybe I say, okay, let me leave that one. And then, okay, let me put something here. Let me say 1. And then I put 1 here. Can somebody call this number for me?
3,412.
Good. 3,412. That's correct. 3,412. Because 400 is under 100. Is it not so?
Yeah.
12. And in abacus, what it means is that if you can, once this one is up to 10, you will not put another word. This one will add more. You understand now?
Yes, sir.
Once this one completes 10, this one will enter 1. Now, if you have 10 here too, it will enter what? It will enter this one. 1 will enter here. So that's how it goes. As you can see, we want to write in figures and equally write in what? Words. So already before now we studied how to write in figures. So all we will do is to take our words. Let's go.
O-N-E 1, T-W-O 2, T-H-R-E-E 3, F-O-U-R 4, F-I-V-E 5, S-I-X 6, S-E-V-E-N 7, E-I-G-H-T 8, N-I-N-E 9, T-E-N 10.
Take it again.
T-E-N 10.
This is what? 11. Let us spell 11.
E-L-E-V-E-N 11.
12.
T-W-E-L-V-E 12.
13.
T-H-I-R-T-E-E-N 13. F-O-U-R-T-E-E-N 14. F-I-F-T-E-E-N 15. S-I-X-T-E-E-N 16. S-E-V-E-N T-E-E-N 17. E-I-G 20.
Take note of these words. Study them. But there's one unique thing I want to let you know. In this case of 1817, watch. You begin to see E-E-N. Is it not so?
Yes, sir.
Take note of this E-E what?
N.
E-E what? N. So that when you say 16, 17, when you spell 7, you put your word tin. You spell 8, you put your word tin. You spell 4, you put your word tin. And that's all. That's how you grab that one. So let's move further. This is 21. Is it not so?
Yes,
21. In this case now, instead of me writing 61, 31, 41, 100 and so, I just want to use this to show you how you can write it. Because once you can write your 20 and you know how to write your 1, that means you can write what? 21. If you can write your 50 and know how to write your 7, you can write what? 57. Is it clear?
Yes,
so there's no need repeating those ones because we have limited time. So in that case, let us spell 21. T-W-E-N-T-Y O-N-E 1. Could be what?
21.
Is it clear?
Yes.
Now let's take 25.
T-W-E-N-T-Y.
You now put your hyphen dash. Eh?
Yes.
And put what? 5. Spell 5.
F-I-V-E.
As what?
5.
So we have 25. In the same way, we have 20 what? 29. Write your 20, write your 9. Write 20 here, put your 9. Is it clear?
Yes,
so
sir.
that is that 29, 39, 49, you can do it. If you need more, look at our textbooks, the basic mathematics. All you do, you go there, we have a lot of examples and exercises for you to do. So get the books, very powerful. Now let this is 30, say 30.
30.
So spell.
T-H-I-R-T-Y.
As what?
30.
Spell 40.
F-O-R-T-Y.
Take note, this 40, some persons might say F-O-U-R, is it not so?
Yeah.
And then put T. That's a mistake, it's wrong. There's no U, it is what? F-O-R-T-Y. As what?
40.
Spell 50.
F-I-F-T-Y. 50. S-I-X-T-Y. 60. S-E-V-E-N-T-Y. 70. E-I-G-H-T-Y. 80. N-I-N-E-T-Y. 90.
And 100, spell.
H-U-N-D-R-E-D. 100.
We will spell 100, we will only write thousands. How do you spell your 1,000? We said 1,000 is like this, is it not so?
Yes.
1,000. So the spelling of 1,000 is T-H-O-U-S-A-N-D. This is what?
1,000.
So if we say 1,000, in that case, it means we will remove something now. We will put 1, is it not so? We put
Yes.
1 and put what? 1,000. This is how we write our what? 1,000. In that case, it will be like this. 1,000. So if you want to write 2,000, you will now write 2 and put what?
1,000.
If you want to write 7,000, you write 7 and put what?
1,000.
Is it clear?
Yes, sir.
If you want to talk about 500,000, let me show you. We have some things I want to write. For instance, we have 500. Are you there?
Yes, sir.
500. Let us spell 5.
F-I-V-E.
5. Is it also?
Yes.
Then 100 will be what?
H-U-N-D-R-E-D.
It becomes what? 500. If I want to write 5,000, as I said before, it will not be what? This is how we write 5,000. Double not. Is it not so? So it will not be what? F-I-V-E 5. Is it not so? Then we write 1,000. 1,000 is what? T-H-O-U-S-A-N-D. To give you what? 1,000. This is what? 5,000. So if I have 569, for instance, 569 is 5 560 what? 9. This is 569. Is it clear? 500 and what? 69. All you do is to write your 5, write your 5 and then write your what? 100. Is it clear? 500 and 60, eh?
Yeah.
60 what?
9.
9. You put any I, any what? E.
Nine.
Can you see now? 500 and then 69. So that is that. We have a lot of them here. We have 10,000 and 30. 10,000 and what? 30. 10,000 and 30. If you want to write something like this, all you need to do is to put what? 10. Is it clear?
Yes, sir.
10. When you write 10, you put your 1,000. THOUSAND. This is what? 10,000. And what?
And 30.
And 30. So I put my and AND as what? And 30. THIRTY. This is what? 10,030. It continues. You can form as many as. If I want to write 20,000, whatever, 500,000 or 1,620. Let me write that one. 1,600 and what? 20. 1,000 here, 600 and what? 20. Let's write that one and see if we can call it a day for here. In that case, 1,000, we write what? 1. Is it not clear?
Yes.
1. O-N-E, 1. Then we want to write 1,000. THOUSAND. Is it also?
Yeah.
1,000. Then 600, Abi?
Yeah.
600. Is it clear?
Yes, sir.
Okay, we need to spell this. 1,000 we can spell 1,000.
Yeah.
6 is what?
S-I-S.
100.
H-U-N-D-R-E-D.
This becomes what? 1,600 and what?
20.
And 20. So let me write 20. You now put your and put your what? 20. And 20 is TWENTY. This is 20. And therefore it is what? 1,620. If you understand the pattern, you can write anything you want to write. You can jump them together, that's all.
So how do I spell 1 million if I want to write 1 million in the bank?
Yes, you can spell 1 million. That's correct. That reminds me, we are supposed to put 1 million here. Million is spelled like this. M-I-L-L-I-O-N. Is it not so?
Yes.
M-I-L-L. Is it clear?
Yes.
This is what? 1 million. Or 1 million. Say 1 million.
Million.
Million. Let me write 1 million here for you. That's good. That's a nice question. So million is 1,0,0,0,0,6 knots. 1, 2, 3, 4, 5, 6. Is it clear?
Yes,
So 1 million, it will be 1. You put your 1 and you put your what? Million. L-L-I-O-N. This is 1 million. This is figure. This is 1.
Excuse me, sir.
Yeah?
Can I still separate comma as I'm putting that red note? The first
Okay, yeah, yes.
Yeah.
In some cases, that's correct, my brother. In some cases, you show there should be a gap. 1, 2, 3, gap. Is it clear?
Yeah.
That's good. So this is what? 1 million. Then if I want to write, say 20 million, all I need to do is to put what? 20. Is it not so?
Yes.
0, 0, 0, and then 0, 0, 0. Is it clear?
Yes,
This
sir.
is 20 what? Million.
Million.
So all you need to do is to write your what? 20. T-W-E-N-T-Y. And then put your what?
Million.
And then that gives you what?
20
million. So if you have 20 million, 800, you don't have to write your 800. You can now add. And whatever, that's all. Lesson 2, simple arithmetic. We call it simple. You see what will happen now. Simple arithmetic. These are the symbols. Symbols, we have plus. We have what? Plus. Addition. We have minus. as what? Subtraction. And this one, multiplication times. Is it clear?
Yes.
We call it times. We call it what? Multiplication. Division. And this sign is what? Equal to. Anytime we put this sign, we are telling somebody that what we have is equal to the other side. So that is equal sign. Then we have greater than. Right hand side, greater than. You can see how it is. Then left hand side is what? Less than. This is what? Less than. In that case, we have square root and we have what? Cube root. But all I will tell you, these two will later treat them as we move on. Take note of these ones. These are the ones we'll play with now. For instance, we have addition. Let's take addition. Oh, can I wipe? Let me wipe. Good. We have addition, for instance, let's have this. Number one, we have 25 plus 30. We want to add. Remember what I told you before? That I said this is unit and this is what? Tens. So you must follow tens to tens, unit to unit. If you have 100, 100 to 100. Don't shift. If you don't do so, so this is what? Addition. In that case, this plus this is equal to what? 5. And this plus this is equal to what? 5. Therefore, what's the answer? 55. Number 2, we have number 2. Number 2, we have 37 plus 42. Plus what? 42. You put your plus and let us add. This plus this?
9.
7 plus 2? 9. And then 3 plus 4? 7. And what do we have? 79. And we have number 3, we have 36 plus 65. You put your plus, 6 plus 5? 11. We put what? 1. And carry what? 1. That one will carry the 1, come here, it becomes what? 4. 4 plus 6? 10. It becomes what? 101. That is that. Okay, let me take 3 figures, 4 figures, 4 digits. In that case, we have something like 207. This is what? 207. 207 plus 393. 393. In that case, let us add 3 plus 7. 7 plus 3. 10. 10. What, do we write the 10?
No.
We do what? We write 0. And carry what? 1. There should be 1 up here. We carry 1. So we carry that 1. 1 to 10 to 9 to give us what? 10 again. And we put 0 and carry what? 1. We carry 1 here. So 1 to 2 to give you what? 3. 3 plus 3? 6. So we have what? 600. So that's the answer. 600. So let's take another one. Number 5. We'll take something like, let me take this one. Okay, let's take something like 9634. Can somebody call that number?
9,634.
So we have thousand, is it also?
Yes.
And we have to add with 283. So therefore 200, is it also?
Yes.
283, this is called for 200. So we put 28 what? 3. And then plus 14, plus what? 14. You see the value 14 will be 1 here, 4 here. Is it also?
Yes.
So we'll now add together. In that case, say 4 plus 3, 7. 7 plus 4,
11.
11. We write 1 and carry what?
1.
That one is coming here. So take that one, put here, because what?
4.
4 plus 8, 12. 12 plus 1,
13.
13. Then we write 3 and carry what?
1.
Carry that one to this place. Then 1 plus 6,
7.
7 plus 2, 9. And we do what? We put 9. And then this one, nothing here, we add what? 9. So what do we have? Call it
9,931.
That is how we do simple arithmetic. I will stop there so far. The issue is that once you can position the figures, the digits, according to units, 100 to 100, 10 to 10, then you will get it right. That's all. So the next one we'll talk about what? Subtraction. We'll talk about what? Subtraction. We've just treated addition. Now I cannot understand what somebody was saying here. We have talked about subtraction. We write what? Subtraction. Subtractions. Is it clear?
Yes.
So in these subtractions, we start number 1. Number 1, we have, okay, take for instance something like this. 46, is it also?
Yes.
Minus 27. So 6 minus 7, can it go? No. Because 7 is greater than 6. So we need to borrow. You come and borrow from me. So we borrow from this 4. We take 1 here, put here. 1 to 6. That one that we're borrowing is 10. So when we add 10 to 6, it becomes what? 16. 16 minus 7? 9. So we have 9. What do we have here remaining?
3.
3 minus 2?
1.
So we have 1. So the answer is what?
19.
We have number 2. Number 2, we say 54 minus 49. 49. 4 minus 9. Can you go? No. What do we do? We add. If we borrow 1, that one is 10. 10 to 4 to give you what? 14. 14 minus 9 is 5. 5 is 5. And then in that case, what is remaining here now? 4. 4 minus 4 is 0. So what is remaining is what? 5. That's the answer. Okay, let's take another one. Number 3. We want to take on 100 minus 99. Minus what?
99.
So let us go. This is 0. 0 minus 9, can it go?
No.
This is another 0. 0 minus 9, can it go?
No.
So we want to borrow. So we have only 1, and this one is 100. Or if we take that one, if we take this one and put here, because what? 10. 10 minus 9. No, we will minus here first. Here that is 10, is it also?
Yes.
So we are seeing invisible 10. That invisible 10 will now borrow from this 10 to here to give us what? 10. Is it also?
Yes.
10 minus 9?
1.
1, Abi?
Yes.
1. How many is remaining here?
9.
So 9 is here now. 9 minus 9?
0.
And already we have removed this one, is it also?
Yeah.
So what is remaining?
Yes.
1. That's all. Okay, let's go for bigger ones, larger digits. Take for instance, number 4. Number 4 will tell you about 5, 4, 3, 3. Can somebody call this number?
5,433.
Okay, let's leave that one. If I write 5009, can somebody call it?
5,009.
Then if I say 576, can you call that one?
576.
This is 500, and that is why we started from 100. And this one is 10. Are you seeing it? You have to be very careful. So in that case, 9 minus 6
3.
is 3. And then here, 0. 0 minus 7, can you go?
It can't
No.
go.
So what do we do?
We borrow.
We borrow. So as we want to borrow, if we borrow from here, is it also?
Yes.
We put here, here will become what? 10. From that 10, we'll have 10 now. From that 10, we borrow 1, is it also?
Yes.
What will remain here now?
9.
So if we borrow 10 here, then here, 1 here, then here, becomes what?
10.
10 minus 7?
3.
3. How many is remaining here now?
9.
9 minus 5?
4.
4. How many is remaining here?
4.
So bring down the 4. So this is the answer. Is it clear?
Yes.
Sir. Good. Then we'll take on another one. Number 5. We want to take larger number and we'll stop there so far. Let's take something like 2076 minus 999. No. Is it clear now?
Yes.
Can we call this number? What is this number? Call this number.
2076.
Take it again.
2076.
So 2076. This is 2000. Is it also?
Yes, sir.
I'll call this one
999.
You see the difference? 900 is not up to 1,000, and that is why we didn't put it under this column. Following our 1,000, hundred, tens, and units. So this minus this, can it go?
No.
We'll borrow from here. 1 to here. 16. Is it not so?
Yes, sir.
16 minus 9. 7.
7.
Is it not so?
Yes.
It's 7. How many remaining here now?
6.
6. Can 6 minus 9?
No.
What will happen?
We borrow.
We borrow here.
Yes,
We
sir.
borrow from here.
Yeah.
Down here to 10.
10.
Carry 1 from 10 to here. Because what? 16.
16.
16 minus 9 again?
7.
How many is remaining here?
9.
9. 9 minus 9?
0.
0. Is it clear?
Yes.
Then how many is remaining here?
1.
1. And we'll bring down the 1 because nothing to subtract. So that's the answer. So we'll stop with what? Subtraction. And we're going to what? Multiplication. Because after multiplication, we're going to what? Division. So one by one, one by one. So if you follow the order, if you want to solve more, just get your textbook. The basic mathematics textbook. Then with it, you can now solve as many as you want. This is multiplication. So on that, let's see what we can do. Let's see something like number 1. We have 23 times 6. Is it clear?
Yes, sir.
So what do? We multiply. 6 times 3.
18.
18. We write 8. Carry what?
1.
6 times 2.
12.
Plus 1.
13.
So we put 13. It becomes what?
138.
So number 2. We have something like 45 times 7. Are you seeing it?
Yes.
So 7 times 5.
35.
35. We write 5. Carry what?
3.
We are carrying 3. So 7 times 4.
28.
28 plus 3. 31.
31.
So we write 31, which is 350. Is it also?
Yes.
So we have number 3. Number 3, we want to consider 2 digits now. 2 digits by 2 digits. We say 24 times 32. Watch what will happen. 2 times, we first of all take this 2. 2 times 4,
8.
2 times 4 is 8, I mean?
Yes, sir.
We write 8. And because I'm multiplying with these 2, I will write it under this column. 2 times 2, 4. We take 3. 3 times 4,
12.
we write how many? 2. Carry what? 1. Carry 1. 3 times 2, 6 plus 1, 7. Therefore, we now add 8 down. Some people may say add 0 here. 8 plus 0 is what?
8.
4 plus 2,
6.
And we bring down what?
7.
The answer is what?
768.
Let's do another one and we'll stop there. Number 4, we have something like 3 digits by 3 digits. 3, 2, 4 times 1, 2, 3. Is it clear?
Yes, sir.
So watch. We start with this. 3 times 4, 12. We write 2, carry 1. 3 times 2, 6 plus 1, 7. 3 times 3, 9. We write 9. 2 times 4,
8.
So you see I'm multiplying with 2. So I will write it under this column. So I will now write 8. 2 times 2, 4. And I will write what? 4. 2 times 3, 6. And then I want to multiply with what?
1.
1. 1 times 4,
4.
1 times 2,
2.
1 times 3.
3.
You see how the thing is shifting? And then we put our plus sign and we add. Some people might put 0, put 0, put 0. These zeros. Are you there?
Yes,
So,
sir.
but watch. Let us add 2 down. Is it not so?
Yes, sir.
7 plus 8,
15.
15. Write 5. Carry what?
1.
1. 1 to here. 10. 10 plus 4.
14.
14 plus 4.
18.
Right, and 8. Carry what?
1.
1 here.
7.
Plus 2.
9.
9. And this one is what?
3.
Can somebody call this number?
39,852.
That would have been the end of our multiplication. But I still have something I want to point out. That thing I want to point out is other forms of what? Multiplication. In that case, look at what I mean by other point. When you are multiplying, if you multiply any number with 0, say any number, even though it's 2 million, with 0 is equal to what?
0.
Take note of that. Any number multiplied by 0 is what?
0.
But apart from that one, if we multiply any number with, we'll say 10, 100 and what? Thousands. I will tell you what happens. Is it clear?
Yes, sir.
I will tell you what happens. Let's multiply by 10, number 1 by 10. If you multiply a number by 10, number 1 by 10, what happens? Take for instance, 25 times 10. All you need to do is able to add 1 0 at the back. It becomes add 0 to give you what? 250. If you have another one, say maybe 376 times 10. All you need to do is to add what? 0 here, because it multiplying by 10. It becomes 37 what? 6 what? 0. Add 0 if you are multiplying. So if you are multiplying by number 2, maybe you are multiplying by say 100. Are we there?
Yes,
If you are multiplying by 100, for instance, let's take that at 25 times 100. All you need to do is to add 2 zeros. It becomes 2501.
0.
What is the figure now? What is
2,500.
Good, 2,500. If we still have 376 times 100, it will now be add 2 zeros. It becomes 37600. Can somebody call it?
37,600.
Good. In that logical order, if I say number 3 by 1,000, are you with me?
Yes,
By 1,000, what will happen now is this. In the same vein, if I assume we are still using 25, say 25 times 1,000, we add 3 what?
Zeros.
In that case, it will be 25000. And who will call this number now?
25,000.
Okay, if we have 376, are you there?
Yes,
Times
sir.
1,000, what you have? You add 3 zeros. It becomes what? 376,000. Who will tell me this figure now? Can somebody tell us? 376,000. There's no other thing here. 376,000. So that is it. When you multiply with 10, 100, and thereabout. The next one we will handle now is division. Is what?
Division.
Division. For division, let us start somewhere. For instance, number 1, if you have 10 all over 5, 10 divided by 5, how many will it go?
2.
2. Somebody will say 2. What if you have 10 divided by 2? What will be the answer?
5.
Is it clear?
Yes, sir.
And you have 20, this is 2, you see 3. 20 divided by 4, what will be the answer?
5.
5. Okay. We have number 4. We have 100 divided by 20. Is it clear?
Yes.
Which there are many ways you can follow this. You can do what I call reduction. By what? Reduction method. Here. What I mean by reduction, they have a common factor. We will learn factor later. So 20, as you, some people will say cancel here, cancel here. Is it clear?
Yes, sir.
So we still have 10 over 2, which is equal to what?
5.
If you still use the 20, it will still give you what?
5.
In whichever way. We can equally use what is called long division what? method. Okay, let me use number 5 and do example of long division method. For instance, if you have something like, I will say 3 divided by 12 divided by 3. 3 here is 4, is it not so?
Yes.
So 4 times 3 to give you what?
12.
12. So it gives you 0. So you know that it has finished. So the answer is supposed to 4. Number 6, we can have something like, okay, say, the same long division, we say 3 by 21. 3 into 21 is 7. So 7 times 3 to give you what? 21. So because if you add, it's equal to 0, you know that the whole thing has what? Finished. Okay, I can still give you number 7. Number 7, let us divide something like 3, a different thing altogether now. Let's see what we will have. And then let's see 741. Is it clear? 741. 741. In that case, 3 to 7, 2. For instance, if this number is too big, assume it's 13. 13 cannot go to 7. I will take it from 74. But because it's a smaller number, 3 can come out from here. So we just go. 3 into 7, 2. Is 2? Yes. Then I write my 2.
Remaining 1.
Remaining 1.
Yeah.
So look at what happened. 2 times 3.
6.
Then I will put 0, 0. Now you subtract. This one or this? This minus this is 1. This minus this 4. 7 minus this 1. That is it. So 3 again into 14. What will go? 3 into 14.
4.
You see 4? So we put 4. 4 times 3. 12. Then we subtract again. This minus this 1. Is it clear?
Yes.
And then this minus this
2.
This minus this 0 is 21. 3 into 21
7.
7. So it has finished. So 3 times 7 21, which is equal to what? 0. So that is long division. So by this we will stop by that multiplication. But division I mean. But there is something I want to add. Take a look at this. If you want to learn more, just get our workbook. Our what? Workbook. Basic mathematics workbook of this DVD or VCD. For instance, we can also do by, I say this is number 8. Number 8 by reduction. Assume we have 126 all over 42. And sometimes if you want to divide, it might be too big for you. You consider, can 2 go? Yes, somebody can use 2. Say if 2 comes here, 6. Is it not so?
Yes.
6. 2 here, 3, which is 63. Is it not so? 2 here, 2. 2 here, 1. 21. Can any other thing go? Yes. 63, this we can say 3 can go. 3 here. We are talking about common factor, 21. 3 here, 7. And therefore, in this case now you can do it, is it not so?
Yes.
So we are using the reduction method.
Correct.
So 7 into this is equal to what?
Correct.
See how we have reduced the body. We can use that pattern. We can at the same time, let me show you another one. Say another one, say number 9. If we have 108 all over 9, which is equals to, what can go? 3. 3 here will give us 36. And 3 here will give us what? 3. Can we still go? Yes. If we care. Although this is the last one now. So let's divide. 3 into 36, how many times? It will give you 12. It will give us what? 12. Very simple. So please, we have to learn all these things. So that without calculator, we can do what? We can subtract and then divide. Division. So there's another one I want to point here. Division of numbers by multiplication of tens. I said it in multiplication. Hundreds and what? Thousands. Let's see what will happen. In that case, have a look at this. We have 55 divided by 10. Is it clear?
Yes.
55 divided by 10. What we will do, because it's 10, it will be what? 5 point what? 5. If we use long division, what I wanted to say there is this. Okay, look at this one. Let's take this one as 1. Look at this one again. 73 divided by 10. Are you there?
Yes.
If you don't understand, it's supposed to be 73 all over what? 10. 10 here will be equal to what? 7. Is it also?
Yes.
Then the remaining will be what? 30. That 30, 10 into 30 will be 3, which is 0.3. So now we have directed numbers. Sometimes in directed numbers, they use lines. I don't want to use lines. But I want to explain to you laws of sines and God maths. These laws of sines and God maths, my brothers, I tell you, if you know these laws of sines, you are a mathematician. It's very simple. What happens with negative, positive, positive, negative, plus, minus, minus, plus. So pay attention now and see what will happen. Here we have addition. And we are telling you plus 6 plus 3. Naturally, if we have any number 3 without any sign, it is believed to have which sign? Positive sign. So it's plus as it is. But we are using this to illustrate so that you will understand very well. Even when this plus is not there, you know that it is what? Plus. Take note. So follow with me as I explain to you now. 6 plus 6 plus 6 is equal to what? Plus 9. Please answer. Equal to what? Plus 9. What it means is that if you have 6 naira in your pocket and you go the other way, you have 3. If you add 6 and 3, how many do you have? 9. Here we have plus 6 plus minus 3. What this one means is that you are owing. So if you have 6 and you are owing 3, if you add them together, maybe you pay. What will happen? You have what?
3.
Plus 3. So minus plus 6 minus 3 add together to give us what? Plus 3. Understand this, you will solve your fractions and whatever. A lot of things in mathematics. Lots of signs. Minus 6 plus 3. You want to add together. Minus here means you are owing. Probably say naira. You are owing somebody 6 naira, and here you have 3 naira. So if you pay, what happens? You are still owing. Is it also?
Yes.
So if you are owing, that is why he said 3 will be remaining. Is it also?
Yes.
To show that you are owing what?
3
minus 3. Is it clear?
Yes.
Now look at this one. Minus 6 plus minus 3. Look at it the other way. We said it's minus 9. How did we get that? We get that by saying that you are owing Nkechi 6 naira and you are owing Adama what? 3 naira. You want to add together how much you owe? 9 naira. That's why we have what? Minus 9. Thank you. In that case, we go into subtraction. We go what? Subtraction. We want to subtract. Watch. Plus 5 minus plus 3. What will be the answer?
Plus 2.
Plus 2. That you have 5 and you want to give somebody 3, or you are owing 3, you want to remove 3. You understand now? So how many will remain? 2. You have given out 3. That is why minus. In this case, you have plus 5 minus, are you there?
Yes, sir.
Minus again, are you there?
Yes, sir.
3. The same is what? 8. Okay, as we move on, you will see that. Minus times minus will give us what? Plus. And that is why we added together. So minus minus to give us what? Plus. So we are now adding together. 3 plus 5 to give us what? 8 plus 8. Take note of these things. This thing you are seeing here is very, very important. Minus 5 minus minus 3. Minus 5 minus minus 3. Minus plus is what? Minus. So minus 5 minus 3 is equal to what? Minus 8. My brother, there's no way you solve your algebra and those things without this. So if I'm too fast, all you do, you can rewind your CDs, go back a little bit, watch it again over and over. Consult our textbook, the Globavasity Basic Mathematics. You see a lot of exercises and you follow them one by one, you will flow. So, follow me as we move down here. We have minus 5 minus minus 3 equals to minus 2. Let's see how we can explain that one. Minus times minus here will give us what? Plus. So it's as if we have plus 3. Plus 3 minus 5.
Minus 2.
Minus 2. Then you have 3 now. You are owing 5. You want to pay. You will have what? Minus 2. This very topic here is very, very important. And that is why I want to spend time to explain the way I'm doing it. Now we go into multiplication. Take note. Plus 2 times plus 3 is equal to what?
Plus
6. 2 times 3 is 6, we know. Plus is equal to what? Plus. Plus 2 times minus is equal to what? Minus 6. Take note, all you should know, anytime you have minus times plus or plus times minus, the answer must be what? Minus. That is what has happened here. 2 plus 2 times minus 3 to give you minus 6. Minus 2 times plus 3 to give you what? Minus 6. Once minus and plus, they are multiplying together, the answer will be minus. But here we have minus 2 times minus 3. What do we have? Plus 6. So take note, minus times minus will give us what? Plus. That is the case. Go over there, we will now talk about division. You see also? Division. We want to divide. The same thing that happens here, equally happens here. In division, 8 divided by 4 is supposed to be what? 2. So we say plus 8 plus 4 is supposed to what? Plus 2. But look at this one now. We have plus 8 divided by minus 4 to give us what? Minus 2. The only thing I want you to understand there is that when we have plus and minus, plus dividing minus or minus dividing plus, because minus and plus is involved, the answer will be what? Minus. This is what? Minus 2. And then minus 8 divided by minus plus 4 to give you what? Minus 2. Take note of these things. Go through it over and over. And then we have minus 8 divided by minus 4. Minus will give you what? Plus. In that case, you have what? Plus 2. That's why you see 2. But what varies is the sign. If you cannot get this, forget about it. No way. So go through your book, do the exercises that I will give to you. In that book, we have more than 50 exercises. Yes?
There's no sign there.
Okay, here.
Yeah.
Okay, this is plus.
Yeah.
Thank you very
And
much.
that's 6.
So this is supposed to be plus 2. Thank you, my brother. Thank you very much. Now we move on. Simple arithmetic. Let me show you. We want to talk about brackets. We want to talk about what? Brackets. Look at what happens. That is where we will apply those things now. When we say board mass, board what? Mass. What does it mean? B stands for brackets. Are we there?
Yes, sir.
Brackets. This is what? Of. D is what? Division. And we have M as what? Multiplication, which is times. And we have A as what? Addition, add, which is plus. And we have S as what? Subtraction, which is minus. So if you follow this, the order is that this is add.
Addition, division. Division
It's
sign.
simple. It's sign.
Okay, the sign. Okay? Okay. Thank you very much. Now what I'm trying to say, board mass. Anything you are doing in mathematics, if you don't follow this order, you will fail. And that is why I told you that what I'm giving to you is called basic what? Mathematics. That if you know them, you have known the other ones. For instance, I will prove to you that your angle of elevation and depression, all those things are no mathematics. The mathematics are what I'm going to teach you here. Those little things, without them, you go nowhere. So let's move on. So in the order, bracket first, of equally means multiplication. Is it clear? Good. Of. Division first, before what? Multiplication, addition and what? Subtraction. Let me show you a typical example of what I mean. Take for instance, you have number 1. You have 3 times 2 plus 4. If you are not very careful, if you do it this way, this plus this, 2 plus 4, 6. 6 times 3, 18. Is it also?
Yes.
18 is wrong. Is it clear?
Yeah.
But what you want you to do, the other side, multiplication before what? Addition. Is it clear?
Yes.
So in that case, let us multiply. 3 times 2, 6 plus what? 4 equal to what? 10. This is what we are teaching you. Take a look at this again. You have something like 3 times into 4 plus 2 equal to. How do we go? Let's say there is bracket, is it not so? So that's why we say bracket first. before of multiplication like that. So there is a bracket, we'll clear the bracket. 3 times this plus this, 6. 3 times 6 is equal to what? 18. If you don't follow it this way, you get it wrong. Take a look at this one. This one is number 2. So I can wipe up this so that I will illustrate. So your board mass, this one will go first before this one. It goes like this. So let's go number 3. Number 3, I want to have look at something. Okay, 4 divided by 2 plus 3. Who will tell us what to go now? What do we do first? Division first.
Division.
Bracket of division. Is it not so?
Yeah.
Yes.
So it will now be 4 over 2. Are you there?
Yeah.
Plus 3. Is it clear?
Yeah.
So 4 over 2. 4 divided by 2 is what? 2. 2 plus 3 is equal to what? 5. So the answer is what? 5. That's correct. So if you understand this order, you will succeed. You have so many exercises in our textbook, basic mathematics, Globavasity basic mathematics to solve. Let me rush. Let me show you what concerns with directed numbers here. We have minus 6. That one should be number 4, Abi?
Yes.
Minus 6 times 3 plus 2 times 5 all over 4 times minus 2. Are we there?
Yes.
sir.
Well, let's see what will happen. How do we do? What do we do? First of all, there is no bracket. Is it not so?
Yes, sir.
There's no bracket. Let's remove this one. There's no bracket. So what we do is that we multiply. Multiplication. Board mass. We multiply before what?
Addition.
Yeah. Before we add. So this time is
9.
9.
no 3 times 6. 18.
18.
Plus times minus is what?
Minus.
Minus 18. You put your plus. This plus. 2 times 5.
10.
10. All over 4 times 2. Plus times minus is what? Minus. 4 times 2 is what? Minus 8. In that case, minus 18 plus 10, who will tell us what will happen? Yes, you are owing 18, you have 10. If you pay, what happens?
Minus 8.
Minus 8. So it will be minus 8. All over what? Minus 8. Which is equal to what? 1. Is it minus 1 or plus 1?
Plus 1.
Plus 1. We told you here that when minus up, minus, now the answer will be what? Plus. So this one has a minus sign, this one has a minus sign. Are you seeing it now?
Yeah.
These are the application. Number 5. We have something like minus 4 times minus 5. Are you there?
Yes, sir.
All over minus 5. Let's work. First of all, minus times minus is what? Plus. 4 times 5 is what? 20. So all over what? Minus 5. So minus dividing plus. This one is plus now, is it also?
Yeah.
Is what? Minus. So 5 divided 20 is equal to what?
4.
Minus 4.
Minus 4.
We'll end it there. We have powers, square, and square roots. Powers. What do you mean by powers? In mathematics, we can also call this indices or indices. Are we there?
Yes, sir.
Indices or indices. Powers. First of all, when we talk about powers, we are talking about if you see something like this, 2 raised to power 2. That's what we call it. Or you can say 2 raised to power 2. 2 raised to power what? 2. 2 raised to power 2. 2 raised to power 2. That's the meaning. In that case, what does it mean? It means 2 times 2. Is it clear?
Yes,
Which
sir.
was the value? Equal to what? 4. 2 times itself. So if you have something like this, 3 square, we also call it what? Square. We also call it what? Square. This 2 raised to power 2 is also called what? 2 squared. You can also put it like this. That it is 2 squared. Squared. Is it clear?
Yes,
2
sir.
squared. 3 squared. This is 3 squared. Or 3 raised to power 2. In that case, it means the meaning is 3 times what?
3.
3 times itself again, 2 times. So 3 times 3 is equal to what? 9. So that is power. If we have 4 raised to power 2, we say it is what? 4 raised to power 2. Or 4 squared. Or what? 4 squared. 4 squared. This is 2 squared. This one will be, say, 4 squared. 4 squared, or 4 raised to power raised to power what?
2.
4, yeah? 4 raised to power 2. That's the meaning of this thing here, we are saying. So let's solve it. 4 times 4 equals to what? 16. That's the answer. But then if you have something, 1 raised to power 0 is equal to what? 0. Is it clear?
Yes.
If you have 4 raised to power 0 is equal to what? 0. It means nothing there. So let's move on. I want to tell you about square root. About what? Square root. Square root of numbers. Say square root. Square root or roots. This is the sign. Square root. When you see something like this, it means square root. When you move from powers, from square to what? Square root. For instance, if we say find the square root of 36. Are we there?
Yes, sir.
From square, what is the square? We are talking about the number that will times itself to give us what? 36. This one now will now be square 6 times what? 6. Is it clear?
Yes,
Which
sir.
is equals to root 6 raised to power what? 2. Can you see?
Yes.
Therefore, because there is a 2 here, with this 2 here, the answer becomes what? Equals to what? 6. In that same order, if I have something like 9, root 9, find the square root of, are you there?
Yes,
That's
sir.
how it will be. Find the square root of 9. Then all you do is equals to 9. Say, okay, 9. What will times itself to give me 9? It is
3.
what? 3. Then you now say root 3 times what? 3. Which is equals to root 3 what? Square. 2 here, 2 here. This root, square root here is 2. It will go off and answer becomes what? 3. In the same way you can do for 25. Let me do here and stop here so far. 25. Square root of 25 will be 5 times what? 5. You think of a number that will times itself to give you 25. In that case, you will answer, okay, 5 times 5 is equals to root of what? 5 raised to power what? 2. Is it not so?
Yes,
Which
sir.
is equals to, these 2 will cancel with this one. What will remain is what? 5.
5.
So you are telling me that in mathematics, you go front, you go what? Backward. In this way, when you say square, we need 5 square will be 5 times square. 5 times 5 will give you what? 25. In the same thing, when you have 25, root of 25, you will now get what? 5. You go this way, you go that way. That is all about that. Let me give you about cube roots. About what? Cube roots. And then we'll end it up there. Cube roots. When we say cube root, we mean cube roots. So for cube roots, what happens? See what happens. Cube roots. Cube roots means numbers of digits or figures 3 raised to power 3. This means what? Cube roots. And look at the sign for cube roots. You put 3 here. Is it clear?
Yes,
This
sir.
is cube root. But when we talk about cube, this is 3 raised to power what?
3.
3, which is 3 cube. Is it clear?
Yes,
So
sir.
cube and what? Cube roots. This is cube roots. That is the sign. So when if we say 3 raised to power 3, it means 3 times what? 3 times what? 3. So let's see the answer. 3 times 3, 9. 9 times 3, 27. But if you have 27 now, maybe the other way, that is the cube root. We can move forward and move backward. For instance, you can have something like this. They put 3 here, put 27. Say find the value, you understand now? Find the cube roots of what? 27. What do you do? What you do is to do the same thing. Cube root meaning 3 times. You say, okay, 27 will be 3 times 3 times what? 3. Is it clear? Which is equal to root, cube root of 3 raised to power what? 3. Because 3 is here, 3 is here, they go off. And the final answer becomes what? 3. In the same vein, we can talk about 2 raised to power 3, which is what?
2 times 2 times 2.
Good. That is 2 raised to power 3. Thank you. I'll call it a cube. In that case now, what do you do? This time, this will give you how many? 2 times 2, 4. 4 times 2, 8. So what if somebody said, find the cube root of 8? They will put like this, put 3. Are we there?
Yes, sir.
Put 3 here. Put 3 here and put 8. What it means, you think of a number and that number is 2. Is it not so?
Yes, sir.
Put like this. You say 3. You say 2 times 2 times what? 2. Which is equals to 3. 2 raised to power what? 3. This one here, then we'll cancel that. And what will remain? 2. That is the way. It continues over and over. Let me give you one example and that's the end. For instance, if we want to apply our, what do you call it, directed numbers, division, multiplications, and what have you, somebody can come and give you questions like this, which they are in our Globavasity basic mathematics workbook. For instance, if you have something like are you seeing what I'm doing?
Yes, sir.
Let's solve. Can you see?
Yes, sir.
So what to do is to find this. What is the square root? The square root of 16. What will times itself to give us 16? 4 times 4 is what? 16. So we will not say 4 is the answer. So we have 4 plus. What is the cube root of 27? What to multiply into 3 times to give us 27?
3.
Is 3.
3.
So we say 3. All over. What is the square root of
5.
25?
5.
I think it's 5.
Yes.
So 5. See what we're having now. Can you see that?
Yes.
Very interesting. These are the application. We are not applying directed number, but mass. In that case now, 4 plus 3 to give us what? 7 over what? 5. It's a fraction. We'll get to fraction later. In this case, this is heavier than this. So we'll divide. So what will it be? It will be whole number 2 over what? 5. This is the answer. Under fraction. But if we want to put it on decimal, we can put it on decimal. But for now, we'll stop here. We have decimal numbers. Lesson 3, decimal numbers. It is important that we understand what we mean by decimals and how to add, subtract in decimals so that we're able to solve our mathematics very well. So for instance, if you see something like 0.5, it is a decimal number. You have something like 10.7, it is a decimal number. 0.15, it is also what? A decimal number. But then, what I will do now is to changing fractions to what? Decimal. So we'll write change. Okay? Capital. Changing fractions to decimals. So if you want to change fractions to decimals, what happens? For instance, we have fractions like 2 all over 5. It's a fraction. Is it also?
Yeah.
We'll get to fraction later. but this is the fraction. We want to change it to decimal. There are two forms. Method 1, see what you do. You may decide to use denominators, equivalent denominators like 10, 100, and 1000. I will show you what I mean by this. In this case now, you want to change it to the denominators, equivalent denominators. What do? You think of a number that will multiply this to give you equivalent denominator like 10. If we want to get 10, 5 times 1 will give us 10. 2, you see not so? So we will now say 2 times 2 all over 5 times what? 2. Are you saying it?
Yes, sir.
In that case, it will be what? 4 all over what? 10. You see not so?
It is.
4 over 10, dividing anything with 10 is very simple. In that case, the answer becomes 10 into 4 cannot, you see not so?
Yes,
Put 0. 10 into 40 will give us what? 4. The answer becomes what? 0.4. Making it very clear, as simple as. We can equally use another style. Like this one, if we have something like 2 whole number, 2 all over 5, what do? We can use method 2, or say the same using the equivalent denominator. In this case, 2 is a whole number, is it not so? Yeah. So we say 2 into times, or say plus, 2 plus 2 times 2 all over 5 times 2, which is equals to 2 into 4 all over what? 4 over 10, which is equals to 2 plus 4 over 10 is 0.4, you see not so?
Yes, sir.
So when you add this together, it gives you 2.4, something like that. If you don't want to go by that, we can actually divide that, say 1, 2, and then 3. We can put it this way. 5 divide 2. This is what we have here. Is it clear?
Yes, sir.
5 divide 2. In that case, somebody will say 5 into 2. Can it go? You say no. We put point here, we add 0. 5 into 20, what goes?
4.
4. So we say 4. 4 times 5, 20. So that's what? 0. So you stop there. We can use this method. Or, say number 4. We can also say, we want to divide 6 by 3. 6 divided 3, can it go? No. We say 0. Put point. Add 0. 6 into 30, 5. 5 times 6, 30. By the time we subtract, what happens? It gives us what? 0. So that's the answer. Here we have changing decimals to fractions. Look at this one, changing decimals to fractions. Now that we want to change decimals to fractions, see what will happen. Changing decimals to fractions. In this case, we are moving from decimal to what? Fractions. See what we do. We have 0.5. Number 1. What do? What you do, the same thing I said before. Now, anytime you see point, this 0.5 is the same thing as 5 all over what? 10. Because this point here will be 1, and this unit here, are you seeing it?
Yes,
this one digit will be 0. So assume 2, if we have 0.05, I will tell you what happens. But let's finish this one. This one is into fraction. This fraction, if you solve fractions and leave it like this, you are in trouble. Because something can still go. So we reduce it to the lowest term. What do we do? 5 up here. 5 cancel itself is what? 1. 5 into 10 is what? 2. So this is the answer. Because our target is to bring it to what? Fraction. From point, decimal. In this case, this one will be 5 all over. This point here is 1. This is 0. This is what? 0. Which is 100. All over 100. 1 here, 0. Double 0. So 5 over 100, what is it going to be? 5 itself to be what? 1. 5 to 100 is what? 20. So it's 1 over what? 20. Take number 3 so that I stop there. If we have something like 4.5, what happens? In this case, we want to turn to fraction. This one is already in a fraction. So what we will do, we'll take this 0.5. It will now be 4 plus 5 all over what? 5 over 10 because of this 0.5. This 4 is a whole number, that's why I say 4 plus. Is it clear now?
Yes, sir.
So in that case now, let's go. It becomes 4, this one is 1 over 2, Abi?
Yes.
1 over 2. So in that case, the answer becomes what? 4 and what? Half. Is it clear?
Yes, sir.
So we can solve and then move on. In our book, we have too many exercises. No much time. Let me go into place value, decimal place values, and see what we can do here. Let me go down, place values, or say decimal. No, capital letter should go up. Decimal place values. Place values or value. Anyone can go. So decimal place values. What I'm trying to say is that the way we consider decimal place values and the normal figure place values, they are not the same. Take for instance, if you have a number like 946.8, this is 853. What it means is that here is our unit. Is it clear?
Yes, sir.
Normal units. This is tens. This is what? 100. Are you there? 100 tens and what? Units.
Decimal. Put decimal.
Decimal, okay. Decimal place values. So in this case, this is the point. Is it not so?
Yes.
We call it decimal what? Decimal point. That's the point, decimal point. After the decimal point, see what happens. This one here, this 8, is under tenth. We call it what? Tenth, not tenths. Tenths, T-E-N-T-H. Tenths. Are you with me?
Yes, sir.
Tenths. And this one is under hundreds. Are you with me?
Yes, sir.
Hundreds. No, TH. With S. Hundreds. And this one is under what? Thousands. What am I trying to say? This one will be divided by 1,000. This one will be divided by what? 100. And this one will be divided by what? 10. Remember I told you from the point. Are you with me? 1, 2, 3. This is 1,100 and what? 10. So if you understand that, you will flow. Okay. Let's talk about addition. Additions of decimal numbers. Addition of decimal numbers. We have addition. Decimal numbers. So, as you can see, we will add, but we'll make it very brief. It's just very simple. All you need to do is just to understand the logic. For instance, you must understand the place values. You must understand what? The place values. For instance, we have 3.04 plus 0.06 plus 5.3. Is it clear? Yeah, let us arrange. We want to arrange, we say 3.04. Is it clear?
Yes, sir.
Now we want to arrange this one here. We put 0 point. Is it also?
Yes.
0, what? 6. The logic is that the points must be on the straight line. We bring in this one. It's 5. The 5 is outside before the point. And you put this point here. Is it clear?
Yes, sir.
And we put our addition. In that way, assume you want to put 0 here, I want to put 0 here, it is carried. If you wish so desire. Now, this plus this is what? 6. 4 plus 0, 0 is what? 4. 0 plus 0 plus 3 is what? 3. Point. This is what? 8. So the answer becomes what? 8.346. This is number 1. Number 2. Let's take another one and probably we may end it there. But the only thing I want you to know is that you must learn to keep your points straight. 36, 2.36 plus 36.75 plus 236.21. Are you with me?
Yes, sir.
Now let us add together. In that case, we want to start from 2.36. Is it clear?
Yes, sir.
Then we want to add 36. It becomes 36.75. Are you seeing it?
Yes, sir.
And then we want to add again. We say 2, that one is far off. 236.21. Can you see what has happened? In this case, the point is there. You arrange it, telling you that this one is hundreds. This one is tenths, not tenths. This one is units, tenths, and what? Hundred. That is the place value. In this case, let us add 6 plus 5, 11 plus 1, 12, 2, carry 1. 1 here, 4, 4 plus 7, 11, 11 plus 2, 13, 3, carry 1. We'll cross over the 1, 1 here, 3, 3 plus 6, 9, 9 plus 6, 15. Are you sure?
Yeah.
15, put 5, carry what?
1.
Carry 1. Okay. 1 here is what? 4. 4 plus 3, 7. And we bring down what? 2. This is the answer. So this is subtraction of decimal numbers. Thank you. So in that subtraction of decimal numbers, we have 7 minus 3.2. What do we do? Number 1. See how you arrange it. This 7 means 7.0. Is it clear?
Yes, sir.
And then you say 3.2. You subtract. 0 minus 2. Can you go? No.
Sir.
Something must be there. Is it also? Yes, we borrow. 1 here, 10. 10 minus 2.
8.
8. We have 8. And what do we have here now? 6. 6 minus 3.
3.
Is 3. So we have what? 3.8. That's correct. Let's take another one. Number 2. Number 2. We have something like 3.5 minus 2.7. All you do is to say 3.5 minus 2.7. 5 minus 7 cannot. So we carry 1, put here 15. 15 minus 7 is what? 8. How many here? 2. 2 minus 2, it remains 0.8. That's the answer. Okay, for the benefit of that, let me give you number 3 and end this one. If we have 6.009 and then you say minus 4.964, let's see what happens. Position them. See the point. All you do, 9 minus 4 is what? 5. This one cannot minus this. You borrow. Collect here, put here 10. Collect from 10, put here.
10.
So here now is 10. 10 minus 6 is 4. What is remaining here? 9. 9 minus 9, 0. Put your point. 6, we have removed 1. 5 minus 4, 1. This is the answer. And at this, I end subtraction of decimal word numbers. It's very simple. All you need to do, get these books. There are too many examples and exercises here. Get it. It will solve the problems. And if you are not too clear, you can fast forward or pause your television, rewind it or move front or back. Anyone at all can go. So the next thing we'll do is multiplication of decimal numbers. So for the multiplication of decimal numbers, this is what we have. Multiplication. Multiplication of decimal numbers. So let's go. So this is number 1. Multiplication. See what we will do. There are little things I want you to see so that you understand what goes on. Okay? In that case, look at this. If we have 0.3 times, are you with me?
Yes, sir.
Times 5. In some cases, let me show you this one. We use conversion to fraction method. Are you with me?
Yes, sir.
So in that case now, it will not be, we want to convert this one to fraction. It becomes 3 all over what? 10. Is it also?
Yes,
This is point over 10 times 5 all over 1. In that case, 3 times 5 is equal to what? 15 over what? 10. In this case, it's a fraction. No, be so.
Yes, sir.
So if you divide, it becomes what? Because 10 now is very simple here now. It becomes 1.5. That's the answer. Number 2, what do we have? If we have 0.2 times 0.5, what will happen? Let's see. All we'll do, we still do the same conversion. In the conversion, this becomes 2 all over 10 times 5 all over what? 10. Is it clear?
Yes, sir.
So 5 times 2 times 5 is what?
10.
All over 10 times 10 is what? 100. So 110, they have a common factor.
Yes.
So 10 can go. 10 here is 1. 10 here is what?
10.
The answer becomes what? 1 over 10. But we are not looking at fractions. We are multiplying. Maybe you want to leave our answer in the other decimal fraction. If you want to continue from here, are you with me?
Yes,
It
sir.
becomes this divided is becomes 0.1. That's the answer. In some cases, number 3, you can have something like 3 1.2 times 1.3. It's very simple. Thank you. Okay. It's very simple. Look at what you do. 31.2 times 1.3. Let's count the decimal places. How many here? 1.
1.
How many here?
1.
So you can multiply without the points. Forget about the points. When you get your answer, you do what? You count the decimal place. So the 3 1 2 times 1 3. Is it clear?
Yes, sir.
So 3 times this.
6.
3 times 1.
3.
3 times 3.
9.
1 times 2.
2.
1 times 1.
1.
1 times 3.
3.
Okay. 6 5
5.
0
1.
4. So when you multiply naturally, you now count your decimal. 1 here, 1 here. Is it clear? 1 here, 1 here. 1 1 1 is what? 2. That's correct. Okay, maybe let me add 4. You know why I said so? If you have something like 6 3 2 5, are you with me?
Yes, sir.
Times 0.5. How many decimal here? 1. How many here? 2. So if we times this one now, the answer is 31.625. Is it clear? The reason is that 1 is here, 2 is here, which is how many now? 3. So after getting your answer, you just do as we did here. All you need to do, you count 1, 2, 3, and you put your point. That's correct. Because 1 here, which is 2. That's correct. I think we end that one there. Multiplying decimals by multiples of 10s. Okay. Let's see. Multiplying decimals by multiples of 10, hundreds and thousands. All you need to do is to shift the point. That's correct. Multiplying decimals by multiples of 10, 100, and what? 1,000. Is it clear?
Yes, sir.
So what you do is just one point there. There will be a shift in decimal point. For instance, if you have something like 0.067, are you with me?
Yes, sir.
Times 10, the answer will be, the point will shift front. Because you are multiplying by 10. It becomes 0.67. It has shifted from this point to what? To this point. Because you are multiplying with 10. If the same number will multiply with 100, see what it will be. If you multiply with 100, it will move from this point towards the right. So it becomes 6.7. Is it clear?
Yes, sir.
When this is 100. If it is 1,000, so it will shift 1, 2, 3. So all you have is what? 61, 7. That's all. Here, estimation and approximation. So all we need to do is here, this is the sign of approximation. We have 3.679 approximated to 3.68. This value here is telling you this one now. This is 9. We approximated this one to 8. It is 2 decimal places. It is what? Corrected to 2 decimal places. Places, yeah, 2 decimal places. And here we have 4.24 approximated to 4.2 to 1 decimal what? Place. 1 decimal what? Place. We have 73.6 to 74. This one now is up to 5. Is it also?
Yes.
We add up this to make it 4. So this one is corrected to the nearest what? Whole number. Are you not seeing? This is the whole number.
Yeah.
This is the point. Corrected to the nearest whole number. So all you need to do, if you want to learn more or you don't understand, you can wind here. You understand now? Rewind it or thereabout. You can check it, study, or pause your television and then work on it. These questions, exercises are in our book, Basic Mathematics, Globavasity. Here we have 1,235 approximated to 1,240. Is it also?
Yes, sir.
This one now is corrected to the nearest what? 10. To the nearest 10. To the nearest 10. Because this is 1,110. Is it clear?
Yes,
sir.
Thank you. We have 5,768 approximated to 5,800. So approximated to the nearest what? 100. Here we have 9,438 approximated to 9,000. So the approximation is on this 9,000 because this is not up to 5. As to say this one would have changed. So what we have is that approximated or corrected to the nearest one, 1,000. The nearest 1,000 is 9,000. The other one is gone. We are talking about estimation and approximation. Thank you. Now we have 867,589 approximated to 868,000. Nearest one, 10,000. This is the 10,000. 68 is 10,000. Tenth of thousands. And then we have these ones. As you can see, look at them. It goes on and on. We talk about 3 significant figures. 3 what? Significant figures. Look at this. 356.27 approximated to 356. We are talking about 3 what? Significant figures. We just want to see 3 figures. That's why you have these 3 significant figures. We didn't bother about this. This other one is 2 significant. This other one is what? 1 significant. Why did we say 1? Enter to 4. Because this is up to 6. So this can change to what? 4. In that order, let's consider numbers like 0.000 before a number. There is what we call non-digit, non-decimal numbers. Look at what I mean. In this case, we say 4 significant figures. We didn't consider this 0. We are talking about 1, 2, 3 figures. The zeros are not included. But there are some zeros that if they were somewhere here, we can do what? We can add them. But these ones here, before these digits, they are not included. So this is 4 significant. Look at this one. This one is how many? 3 significant. This one is how many? 1 significant. That is it. Thank you very much. As you can see, this is lesson 4. Say lesson 4.
Lesson 4.
Good. Even numbers. Even numbers 1 to 100. What is an even number? Even numbers are numbers that 2 can divide without any remainder. Is it clear?
Yes, sir.
Any number that is divisible by 2 without any remainder is what? Even numbers. This is 1 to 100. If you read here, it's 1 to 3, down to 100. But this thing we are seeing here, these ones I circled here, they are what? Even number. 2 is an even number. 12 is an even number. 92 is an even number. 82 is an even number. Yes, numbers. 2 can divide them without any remainder. The same thing happens here. As you are seeing them inside this block here, they are even numbers. Here, 10, 20, 30, down to 100. They are what? Even numbers. Take note of that. We will use them later to apply. We are talking about prime. No, let's leave prime. This is what? Odd numbers. Say odd numbers.
Odd numbers.
Odd numbers 1 to 100. Odd numbers 1 to 100. What is odd numbers? Odd numbers are numbers that 2 cannot divide without any what? Remainder. If 2 divide them, there must be what? A remainder. 2 cannot divide them in short. Numbers that are not divisible by 2. Numbers that 2 cannot divide, they are odd numbers. As you can see here, we have 1, 11, 21, down to 91. If 2 divide 91, it cannot go. It will be 45 with 1 remainder, so it cannot go. So all these numbers here, they are what? Odd numbers. See this column again, odd what? Numbers. See here again, odd what? Numbers. In fact, here we have 50 even numbers, 50 odd numbers. The same thing here, 50 even numbers and 50 what? Odd numbers. This one is nice and odd number. 10 is what? Even number. So here, these ones here, they are what? Odd numbers. So you can pause your television to have a glance of it and study on your own. If you need more, you can go through our textbook, the workbook of this DVD VCD. We have here prime numbers. Prime numbers 1 to 100. Prime numbers 1 to 100. What am I trying to say? What are prime numbers? Prime numbers are numbers that no other number can divide except 1 and what? Itself. 1 can divide it and what? It what? Itself. No other number. For instance, 2 is a prime number. 2 can divide itself and 1 can divide what? 2. 3 is a prime number. 3 can divide itself and 1. No other number apart from 1 and itself. 7, as you can see. 11 is a prime number. 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, and 59. We have here 61, 67, 71, 73, 79, and here we have 83, 90, 89, and what? 91 and 97. There are 26 of them that are prime numbers 1 to 100. At this point in time, let's move on to multiples. What? Multiples. We must know multiples. So that when somebody says 9 times 6, you tell us the answer because you know your what? Multiples. Multiples, I mean, means multiplications. Numbers that can multiply to give us a certain number. For instance, this is 2, as in, let's call this one times table. They call it what? Times table. This is 2. 2 times 1, 2. Let us read. 1 to go. 2 times 1, 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. 2 times 6, 12. 2 times 7, 14. 2 times 8, 16. 2 times 9, 18. 2 times 10, 20. 2 times 11, 22. 2 times 12, 24. As you can see, watch the board. We have 2 times, we have 3 times, 4 times, 5 times. Are you seeing them?
Yes, sir.
Good. But one thing I will not do is to do what? Is to take them one by one. A lot of times will be consumed. So all I want you to do is on your own, pause your television on that area and read it. So let us read 10 and read 12. Let us go. 10 times 1, 10. 10 times 2, 20. 10 times 3, 30. 10 times 4, 40. 10 times 5, 50. 10 times 6, 60. 10 times 7, 70. 10 times 8, 80. 10 times 9, 90. 10 times 10, 100. 10 times 11, 110. 10 times 12, 120. 120. Let us read 12 times, which is the last. 12 times 1, 12. 12 times 2, 24. 12 times 3, 36. 12 times 4, 48. 12 times 5, 60. 12 times 6, 72. 12 times 7, 84. 12 times 8, 96. 12 times 9, 108. 12 times 10, 120. 12 times 11, 132. 12 times 12, 144. I cannot read up. You can pause it and begin to do the work yourself. we have LCM, which means lowest common what? Multiples. How do you find your LCM? Very, very important. Because if you understand your LCM, what does it mean? It means you can solve your fractions and do so many things with LCM. So pay attention. And another thing, if you understand this LCM, in the same way you do your algebraic LCM. So pay attention. Number one, for instance, we say find the LCM of 2, 3, and what? 6. What you do is to put 2, put your 3, and put your what? 6. In that case, you think of what we will divide. Factor. What is that factor? 2. 2 can go, is it not so?
Yes.
2 into 2 is 1. 2 here you cannot, is it not so?
Yes.
2 into 6 is what? 3. 2 is gone. What do you think will go? 3. 3 can go, we say 3. 3 here is 1. 3 here is 1. It is finished. Therefore, LCM, the very LCM of 2, 3, and 6 is equals to what? 2 times what? 3. Okay, 2 times 3, my brother. Thank you very much. 2 times 3, which is equal to what? 6. That's the LCM. Number 2, we can actually say find the LCM of what? Of 3, 6, and 5. Is it clear?
Yes,
So that logical order, what you say 3, you say pattern, you say 6, and you say what? 5. And you draw. You think of which number can go? 2 can go here, is it not so?
Yes,
We say 2. 3 cannot go. 2 here is 3. 2 here, nothing concerning it. It can go. What do you think will go? 3 can go. So that's why we talk about lowest common this thing. So 3 will go. 3 here, 1. 3 here, 1. 3 here, it
You
cannot.
can't bring 5 down.
So we bring that. So 5 will go now. 5 here, 1, 1, 1. Is it also?
Yes.
Therefore, the LCM of 3, 6, and 5 is equals to 2 times 3 times 5. Let's see what it will give us. 2 times 3, 6. 6 times 5, 30. You cannot see the application of our multiples. So this is 30, and that's the answer. Let me give you the last for this LCM. Okay, somebody will say, find the LCM of, let's say, find the LCM of, let's change the figures, let's say, 3, 8, and 24. Is it clear? 24. In that case, we have 3, we have 8, and we have what? 24. So 2 can go. 2 here is 4. 2 here is 12. Is it not so?
Yes, sir.
So what will get again? 2 because of this. 3, no, 2 here. 2. Huh?
Yes.
This one will be 2. 2 can go to 4. 2 here is 6. Is it not so?
Yes.
2 can still go again.
Yeah.
3 will come down. 1 and 3. What do you think will go? 3. 3 here is 1. Is it not so?
Yes. 1 also.
And then 1 also.
And 1.
And what? 1. So it has balanced. Therefore, LCM of, is it clear?
Yes.
LCM of 3, 8, and 24 will be equal to 2. Is it clear?
Yes, sir.
Times what?
2.
2 times what?
2.
2 times what? 3.
3.
Which is equals to. Let's go and see what we have. 2 times 2, 4. 4 times 2, 8. 8 times 3,
24.
So it's 24 is the LCM. That is that for the LCM. We'll go into the highest common factors. Highest common factors. For highest common factors, you need to pay attention. Because even when you are handling your algebra, which will, in our next study now, that's what we will do, you will discover that with your knowledge of highest common factors or factor in general, it will help you even to cancel and then cancel, to know what will go here and go here. It's very, very important. So pay attention. That's why we call them basic mathematics. Basic mathematics are those mathematics you learn. Once you learn them, you are there. You can solve. You can even learn on your own. So let's talk about HCF. What is the meaning of H what? CF. It means highest. Highest what? Highest common
Factors.
Factors. Highest common factors. Highest. When we talk about factors, we are not talking about the highest. So let's see what will happen. For instance, before we talk about HCF, we first of all talk about what? Factor. Common factor. That is CF. And what is a common factor? A common factor, maybe let's say in a family or in a village, we want to talk about the common factor of a people. It means in that village, what this family has, the other one have it, the other one, are you with me?
Yes, sir.
That is very common. That is common factor. If it is bicycle, you know that almost everybody in that village has what? Bicycle. Understand it that way. That is common factor. It is from common factors, we will now talk about the highest one. Common. The highest. It could be that everybody has spoon. Everybody has bicycle. But the highest in that village is Okada. Are you with me? The highest could be car. So we are talking about the highest. First of all, let's go into factors first. If I tell you, if we have something like 16, what is the common factor of 16? Common factor of 16. Numbers that can multiply to give us what? 16. 1 can multiply with 16 to give us what? 16. 1 times 16 is what? 16. 2 can multiply with 8. Is it not so?
Yes, sir.
So 4 can multiply with 4. Is it not so?
Yes, sir.
And then so we have 8 and what? 16. These are factors of what? Common factors of 16. So if we have something like 32, and I want to find the common factors of 32, 1 can go, 2 can go, 4 can go, 4 times itself times 8 to give you 32. And then 8 can go, 16 can go, and finally what? 32 times 1 will give you what? 32. So these are common factors of what? 32. And then let's talk about 40. Common factors of 40. We'll talk about 1. What again do we do? 2. 4. 4 times 10 is 40, isn't it also? 5 times 8 is 40. 8, 10, 20, and what? And 40. These are common factors. But if we have these common factors and we want to find the highest common what? Factor. Somebody can say, question number 1, find the highest common factor of 16, 32, and what? 40. What you do, you first of all find the what? Common factor. We want to talk about the highest. Consider, we have 2 here, 2 here, 2 here. Is it not so?
Yes, sir.
But it's not the highest. We have 4 here, 4 here, 4 here. Is it the highest? Remember I told you in the village, they have spoon. We are not talking about the one, the lowest. We are talking about what? The highest. Here we have 8, and that's the highest. Therefore, the highest common factor of 16, 32, and 40, HCF, are you with me?
Yes, sir.
Is equal to what? 8. Look at it here. And that's the highest number that they have in common. But there is another way you can find it. Let me show you. Method 2. This is said method 1. If I say method 2, method 2 will be write 16. Are you with me?
Yes, sir.
Write 32 and write what? 40. As if you want to do it in form of LCM. And then we say 2 can go. Is it not so?
Yes, sir.
2 here is 8. 2 here is 16. 2 here is what? 20. Is it clear?
Yes.
And then we say 2 again can go. 2 here is 4. 2 here is what?
8.
2 here is what?
10.
What again can go?
2.
2 here.
2.
2 here.
4.
2 here.
5.
5. You cannot see that no other number that can go uniformly. So it stops there. Because 2 cannot divide this one. Is it not so?
Yes.
3 cannot go. 4 cannot go. So that's the end. Therefore, highest common factor of 16, 32, and 40 is equal to, look at it here, 2 times 2 times what? 2, which is equal to what? 8. 2 times 2 is 4. 4 times 2 is what? 8. That's that. I think with this, I stop here so far. Here we have lesson 5, fractions. In this case, we want to solve fractions. And before I start with fractions, I want to ask, what is a fraction? A fraction simply means a part of a whole number. For example, if you have an orange, a whole orange, 1, and you share like this is called what? Half. And this is another word, half. Half is a fraction. If you have the same orange, and you share it into 4, one part of it is what? 1/4. We call it 1/4. Say what?
1/4.
Meaning that one thing divided into 4 places. This is 1/4. And it goes on and on. Therefore, when I talk about fractions, we say something like this, fractions. Things like this are fractions. Say 1/2, they are fractions. 1/3, they are fractions. 1/4, fractions. 3/4. And then 2/what? 2/3 or 2/4. etc. 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 These are fractions. In fractions, there is another thing I want you to know. We talk about proper fractions and what? Improper fractions. So if I say proper fractions, what do I mean? Proper fractions. Proper fractions. What do I mean by proper? A fraction is said to be proper when the numerator is less than the denominator. In a fraction, that reminds me, if you have 2/3, this is the what? Numeration. Say what? Numeration or numerator, and this one is what?
Denominator.
Numerator and what? Denominator. Are we there?
Yes, sir.
We have numerator and what? Denominator. So when I talk about proper fractions, I mean a fraction whereby the numerator is less than what? The denominator. It is proper. In the first instance, what is the meaning of the English proper? Proper means when something is normal. Is it not so? It is normal for a father or elderly person to carry a small person. Is it not so? So in the case of numbers, fraction, when you have 2/3, it is what? A proper fraction. It means it is a normal thing. When you have something like 1/2, it is what? A proper fraction. If you have something like 3/7, it is what? A proper fraction. Meaning that the denominators are greater than the what? The numerators. It's proper. And if you are solving, you can leave something like this to go. So we have improper. We have what? Improper fractions. Say fractions. Say improper fractions.
Improper fractions.
Then what is improper? Improper is the opposite of what? Proper. Is it clear?
Yes, sir.
We are talking about proper. The opposite of proper is what? Improper fractions. Look at them. Improper fractions. In that case, the numerator is greater than what? The denominator. Meaning that small pikin, small number is carrying big one, and the load is too much on it. That's why we say it's improper. For example, if you have something like 5/2 or 7/3, they are what? Improper fractions. Or even 100/60, it is what? Improper fractions. It goes on and on. But there is something we will do later. I will tell you, when we have improper fractions, we can change them to mixed numbers. Mixed what? Mixed numbers. That's our next course of action. Let's talk about mixed numbers. So we have mixed numbers. In mixed numbers, what do we mean? Or mixed fractions. Say mixed fractions.
Mixed fractions.
Mixed fractions. Mixed fraction means it has a whole number and what? And a fraction. It is mixed. In that one, you have whole number, you have a fraction. It is called mixed fractions. For example, if you have 2 whole number, 1/3, it is called what? Mixed fractions. If you have 3 whole number, 2/6, or 3/6, or whatever, 7, or anything at all. 4 whole number, 1/3. They are what? Mixed fraction. Look at the mix. This is a whole number. This is a whole number. This is a whole number. They have whole number and a fraction. Whole number and a fraction. Whole number and what? Fraction. That's why it is mixed. So apart from that one, the next thing we will consider is reducing to the lowest term. Reducing to the what? Lowest term. This is where people fell jam. Jam will set the question. At the end of the day, they will leave the question. They will give you answers. The big one will be there, the smaller one will be there. So they want you to use your brain, because we don't solve by leaving answers high. You must reduce to the lowest what? Lowest term, lowest term. We call it lowest term. Set the lowest term.
Lowest term.
Lowest term. For example, they will say simplify, evaluate, solve. Things like that, they are things you see in our textbook. This book here, in our textbook. Basic mathematics workbook. This is a workbook on this VCD DVD. Every damn thing. You have too many exercises here. You work, examples. After the examples, you see the exercise. After the examples, so you follow. But here, there is no time. And that is why we have decided to do it the way we are doing it. Reducing to the lowest time, look at what I mean. 8 all over 24. You solve and you have something like this. Is it proper or improper here?
Proper.
It is proper. But even though that it is proper, it's still not correct. We need to reduce it to the lowest one, term. In that case, I talked to you about factors. What is the thing that can divide here and divide here?
2.
2 can go. 2 here is 4.
Yeah.
And 2 here is what?
12.
12. What do you think will go again?
2.
2. 2 here 2.
2.
2 here 1.
6.
What do you think will go
2.
again? 2. 2 here 1.
One.
And here 3. Okay, thank you. This is the answer. 8 can keep itself and go to here to give us what? 3. But if you cannot do the high number, do it bit by bit. That's all. Let's take another one. If we have something like 30 all over 45, can we reduce now? What do you think can go? Can 2 go here? No. Can 3 go? Yes.
Yes.
3 here, 10. 3 here,
15.
What do you think can go again?
5.
5 can go, my brother. So 5 here now,
2.
5 here, 2. And 5 here,
3.
3. So it becomes what? 2 over 3, I mean. My people, let me tell you, if you are solving, you must always get your answers this way. If you leave it somewhere here, you are failed. Basic mathematics, very, very important. So let's do one thing now. Let's rush. A situation whereby we will say, changing from improper to mixed fractions. Say, changing. Are you with me?
Yes, sir.
Improper to mixed fractions. Look at it. Changing from improper to mixed fraction. Look at the improper there. Improper means 6 all over 4. It's improper, isn't it also?
Yes, sir.
So let's to mix. 4 divide 6. How many times? 1. What is remaining? 2 all over what? 4. If you leave this answer like this, you are still not right. Something can still go. The final answer will be one whole number. 2 can go here, 2 can go. Isn't it also? Therefore, it will be 1 over what? 2. That's the final answer. Correct answer. And then let's do another one before we leave this area. Another one, this is number 1. Number 2. Number 2, I will take something like 7 all over 3. 7 over 3. How many times? If 3 divides 7, how many?
2.
2.
Remember.
If you are solving and you leave your answer like this, you have failed. So if 2, how many remainder? 1 over what? 3. This is the final answer. And that's the correct answer. And that's what we want from you. Another changing again, we can change again. We will change again. Watch. Let me show you. Changing from, which one is this? Improper to mixed fractions. Now we change from mixed fraction to what? Improper fractions. Changing from what? Mixed.
fraction.
You see, I told you mathematics. We go front, mixed fractions. Mixed fractions to what? Improper. Improper fractions. Improper fractions. So if we want to change from mixed to improper, look at it now. We have number 1. We have 2 whole number 1 over 3. Is it also?
Yeah.
It is mixed fraction. So we want to change to improper. What do? 2 times 3.
6.
6 plus 1.
7.
Did you see what I did? Times plus 6. 2 times 3. 6. 6 plus 1.
7.
7 over what?
3.
That's the answer. Number 2. Oh, I think I will stop here. I will show you another one again. Number 2. If you have 3 whole number 1 over 3, what does it imply? You do the same thing. This is called multiplication. And here you add plus. Therefore, 3 times 3.
9.
9 plus 1.
10.
That's why I say 10 over what? 3. This is the final answer. This is improper. This is improper. So we're changing from mixed to improper. Mixed to what? Improper. That is that. Another area I will go into is addition of fractions. Addition of what? Fractions. We add additions, we subtract, we divide, we multiply. And then that is all about fractions. So let's go into addition of fractions. As you can see, addition of fractions. Addition of fractions. So, good. Here we are. Number one. Addition of fractions, number one. We have something like 1 over 3 plus 2 all over 3. Now, the market, the business, we have arrived. Watch. That is one reason why I taught you LCM before this time. In this case, you cannot add. You must find what? LCM. First step. So first step, LCM. What is the LCM of 3 and 3? Is what? 3. I will not find time to find LCM. We'll go straight because I've shown you how to find LCM. LCM of 3 and 3 is 3. So we'll write 3. 3. This 3 will come here. 3 divided 3. How many times? 1. 1 times 1. You say what the word? 1. 1. So I put 1 and put my plus. And then this 3 will come to this one. How many times? 1. 1 times 2. You say what's the word? 2. That's why I put my what? 2. In that case, 1 plus 2 is equal to what? 3. Over what? 3. 3 over 3. 3 divided is equal to what? 1. That's the answer. So if I have number 2, and I have 1 all over 3 plus 2 all over 5, what do you think will be the LCM of 3 and 5? Who will tell me? 15. The LCM of 3 and 5 is what? 15. Remember, I taught you how to do so, but I don't want to repeat it again. I'm very fast, as you can see. So the LCM of 3 and 5 is 15. If you are confused, you can go and find out. Use as method. 3 into 15, it will be how many times? 5. 5 times 1 is what? 5. 5. You put your plus. 5 into 15 is what? 3. 3 times 2, 6. So what do we have now? If you add 5 plus 6 is what? 11 all over what? 15. This is the final answer. You cannot reduce again. Nothing can go. So I pick on another one. Let me take something like this. Good. What if we have this one? Something like this. 2 whole number 1 over 3 plus 5 whole number 1 over 4 plus 1 whole number 2 all over 6. You see the maths now, some people, their mind will cut. Say they have seen mathematics, there's nothing here. First of all, you have to change to improper fraction. What do you do? 3 times 2? 6. Plus 1? 7. Which is 7 over what? 3. Are you saying that? You put your plus. And then you say 5 times 4? 20. Plus 1? 21. All over what? 4. You put your plus. You see, I'm changing these mixed fractions. You must change this way. And then 6 times 1? 6. Plus 2? 8. All over what? 6. Is it clear? Then what is the LCM of 3, 4, and 6? It is 12. It is what? 12. So I will say the LCM of that is 12. So if 3 comes to 12, how many times? 4. 4 times 7. 7 times 4, 28. You say plus. And then 4 comes here. 3. 3 times 21. 63. And you say plus. 6 here, 2. 2 times 8, 16. Now let us add. We must add. This plus this plus this plus this. What are we going to have? This here is 80, 91, 101, 117, 117 all over 12. You now divide. Can somebody divide for us? What will be the answer? So next one, we're going to what? Subtraction of what? Fraction. So subtraction of what? Fraction. So once you follow the order, there's nothing there. Follow the order. If you need to solve, if you need exercise, we have each topic more than 50 questions, bit by bit, from small to complex. So get the book, the Globavasity Basic Mathematics Workbook. You will see something. So let's go into fraction. subtraction of fractions. What we did now is what? Addition of what?
Fractions.
Addition of fractions. Good. So, watch. We have subtraction. Subtraction of fractions. Are we there?
Yes, sir.
Good. That's subtraction of fractions. Watch what will happen now. It's just the same way. Number one. What we do? We say 2 all over 3 minus 1 all over 3. In that same way, what is the LCM? LCM of 3 and 3 is 3. Is it also?
Yes,
It
sir.
is. 3 into 3 will give us what? 1. 1 times 2 is what? 2. Minus. Put your minus. 3 into 3 again? 1. 1 times 1? 1. In that case, let's subtract. 2 minus 1 is what? 1. All over what? 3. That's the answer. Number 2. If we have 2 whole number, 2 not 2 whole number, 2 over 3 minus 1 all over 2. What's the LCM of 2 and 3? 6. 3 into 6 will be how many times? 2. 2 times 2? 4. You put your minus. And then 2 into this is 3. 3 times 1 is 3. 4 minus 3 is 1 over 6. That's the answer. I will do a bigger one, and we'll leave the rest till next time. So number 3, if we have 6 whole number, 2 all over 3, and we have minus 5 whole number, 1 over 4, what do we have? All you need to do, something like this, is that you must change these mixed fractions to improper fractions. 3 times 6, 18. 18 plus 2, 20, all over 3. Minus 4 times 5, 20. 21 all over 4. What is the LCM of 3 and 4? It is 12. I have taught you LCM before. I don't want to waste my time. 12. 3 into 12 is 4. 4 times 20. 80. Minus 4 into 12. 3. 3 times 21. 63. Is it not so? So 80 minus 63 will give us how many?
17.
17, my brother. 17 all over 12. I don't want to worry my brain. And in this case, nothing can reduce. Okay, look at that thing I was telling you. If you leave the answer like this, you have failed. So you say, okay, 12 can go here, is it not so?
Yes.
So 12 into 17 is 1.
1.
5 will remain. 5 all over what? 12. This is the final answer. Then we go into multiplication of fractions. Multiplication of fractions. Multiplication of fractions. Number 1, how do you multiply? First of all, if you have 1 all over 2 times 1 all over 2, which is half times half. My brother, all you need to do, very simple. In terms of multiplication, you say numerator to numerator, denominator to what? Denominator. You can multiply. You can cancel out common factors and get your answers. That's all. What we mean, 1 times 1 is equal to what? 1. In this case, there's nothing like finding LCM, no way. So 2 times 2 is what? 4. So the answer is what? 1 over 4. So number 2, what do we do? Look at it now. If I have something like, let me give you another one. 1 all over 2 times 2 all over 3 times 3 all over 5. In case you have something like this, I will show you 2 ways you can handle this matter. What you do? 1 times 2,
2.
2 times 3,
6.
it's a 6 all over. 2 times 3,
6.
6 times 5, 30. Are we there?
Yes, sir.
And in that case, what do? You say, okay, 30. Something can cancel. It's not so 2 here,
3.
2 here,
15.
3 can go.
Yeah.
3 here,
1.
3 here,
5.
5. This is the answer. But if you don't want to follow that one, we can say or. This one now we say 1 all over 2 times 2 all over 3 times 3 all over 5. look at what will happen. 2 can cancel 2. Very simple. 3 is here. 3 can cancel 3. Is it not so? So what you have, 1 times 1 is 1. All over what? 5. You can do it this way or that way. With this, I will say over. But then I must say something. Anytime you are solving and you see off, maybe 2 over 3 of 1 all over 4 is telling you the same thing as 2 all over 3 times 1 all over what? 4. Off means multiplication. I will round it off here, there is no time. In that case, I will go into division of fractions. In the case of division of fractions, see what will happen. Very simple. Check our textbooks. A lot of exercises are there, from simple to complex. Please do that. You will not regret it. It's very comprehensive. Check inside and see. Division of fractions. Are we there?
Yes,
Division
sir.
of fractions. In the division of fractions, one thing you must note. There's nothing there, I may not go too deep. Because division and multiplication, they are what? The same. One unique thing is that you change. There must be a change. Changing your division sign to what? Multiplication. And what else do you do? When you change, you see what I'm trying to say. You invert. Invert the fraction. Or fractions. The fraction. This thing, let me explain. For instance, you have 1 all over 3 divided by 2 all over 3. My good brothers, see what you do. Division is the same thing as multiplication. All you need to do is 1 all over 3 times, you turn this one upside down. 3 will go up and 2 will come down. That's all. In this case now, it becomes multiplication of fraction. Is it also? You can solve from here. 1 times 3 is equal to what? 3. 2 times it is 6. You can say 1 all over what? 2. That's the answer. So, let me do another one and leave that area. For instance, if I say this is number 1 and say this is number 2, and I have something like 2 whole number 1 over 4, and then divide by 1 whole number 1 over 4. My good brother, very simple. All you need to do, 4 times 2, 8, plus 1, 9 all over 4. Divide by 4 times 1, 4 plus 1, 5. 5 all over 4. Very simple. In this case now, you have changed it this way. And then you will enter the next level. What is the next level? You will reverse. 9 all over 4 times, you want to change. You have changed division to multiplication. You now turn. 4 all over what? 5. That's all. If you multiply this by this, it will give you a number. Multiply this by this, 20. But if you don't want to go by that, you say 4 here 1, 4 here 1, common factors. All you now have is 9 all over what? 5. 9 over 5, if you leave it like this, you have failed. That is jam. You don't leave it. So what do? You divide. How many 5s are into 9?
1.
1. How many remainder? 4 all over 5. This is the answer. And this is why I call it a day for that division of fractions. But there's one thing I must let you know. If I don't do so, you have been cheated. Look at what will happen. We have what is called board mass. Say what?
Board mass.
Some time ago, I made mention of board mass. Here, I want to show you what happens. It's very simple. Once you know how to solve your addition, multiplication, like that, it's very simple. In this board mass, see what you need to do. All you need to do here is for you to follow the order. Bracket of division, multiplication, addition, and what?
Subtraction.
You must follow them orderly. For instance, if I have something like 1 over 3, 1, times, into bracket 2 all over 5, plus 1 whole number, 1 all over 2. Are you with me? And I say solve. Bracket of, there's a bracket here. So I must finish what is in the bracket. So I put 1 over 3. I will put my multiplication. I want to solve this and bring it in. No, let me leave this off first. So this becomes 2 all over 5 plus, I will change this one. 2 times 1, 2 plus 1, 3. It becomes 3 over what? 2. In this case now, I want to solve. 2, the sum of 2 and 5 is 10. 5 here is 2. 2 times 2 is 4. Plus 2 here, 5. 5 times 3, 15. Is it not so?
Yes, sir.
This for this is 19 all over what?
10.
This one now, I will now carry it. 1 all over 3 times, the whole of what is in bracket is this. Is it not so?
Yes, sir.
When I say 19 all over what?
Yes.
10.
Is it not so? Therefore, you can say 1 times 9 is what? 1 times 19 is 19. 3 times 10 is what? 30. Check. If anything can reduce here, reduce here. I don't think there's anything. For that reason, this is the answer. Lesson 6, algebra. At times, some people, when they hear algebra, they get confused. Algebra simply means the use of letters, alphabets, in solving mathematics. That's algebra. But there are things you must understand, the basic things, and that's what I want to teach you now. Somehow, I will be very fast, but you try to follow me because there's no time. As you follow me, if you get confused, you can pause your television, you can rewind, you can go front, you can go back, that's all. So let's go. Here, algebra, we are talking about addition. Say what? Addition. In addition in algebra, A plus A is equal to what? 2A. Say 2A. 2A. 2A in the other way could mean 2 times A will equally give you what? 2A. A plus A means, let's take A to be apple. 1 apple plus another apple. How many apples? 2 apples. That's why I say 2A. But here I will say 2A plus 3A is equal to how many? 5A. You have 3A, 2A plus 2A is equal to 5A. In that way, the only way you can get that is by saying 5 times A will equally give you what? 5A. Are we there?
Yes, sir.
Here we now have 2y plus 3y is equal to what? 5y. Just like what you have here. The number can vary. I may decide to remove 3 here and say, okay, let's use 2. And this one will change to what? 4. Very simple. That way, if I say 5 times y will give us what? 5y. If it is 4, 4 times y will give us what? 4y. If you know these things, you will solve your maths without no hitches. And then look at this one again. A plus B is equal to A plus B. What am I trying to say? I am saying that you cannot add A and B. Take for instance, A means apple and B for banana. And you said you have 1 apple plus 1 banana. What will it be? You still have what? 1 apple plus 1 banana. Because you cannot add them together. And that is why I said not like terms. They are not the same. They are not like terms. So here, the same thing happens. X plus y is the same thing as what? X plus y. You cannot add. You cannot. Even though you have 2x, no, you cannot. Because y and x, they are not the same thing. You can't add. They are not like terms. Here we have 2t plus 3k is the same thing, not like terms. A square plus a square. How many a square now? 2a square. And how can you get 2a square? That is 2 times a can at the same time give you the same thing as what? 2a square. Remember I told you about square. Means a raised to power 2. A raised to power 2. 2a raised to power 2. And here we have 2a raised to power 2 plus a. You cannot add these two together. Is it clear? Yes. Because they are not what? Like terms. That's why the answer will still be 2a square plus a. They are not like terms. And here we have 3a square plus 5a square. You see that this is a square, is it not so? Yes. So you have 3 here, you have 2 here. Finally, what do you have? 5a square. I tell you, if you understand these things, you are on your way to knowing mathematics. I said coefficient. What do I mean by coefficient? If you have something like a square and you have 3, therefore 3 is the coefficient of what? A square. If you have 2b, therefore 2 is the coefficient of what? B. Coefficient, the number that is attached to it. Let's go over to subtraction of algebra. the laws. These are the basic laws which you must know in order to succeed in algebra. If you don't know this, don't play with it. Make sure you study them to know these things. If you know these things, your expansion and factorization, all those things will be simple. But without this, you will go nowhere. With this and your directed number that we have treated before, you are on your way to becoming a mathematician. Chikobi in that matter. Now let's go. 2a minus a. You have 2a minus a. What will remain? 1a. That is why we are saying a. So we don't write 1a. It is a. A means 1a. You have 2a square minus a. Will remain the same thing as what? 2a square minus what? A. The reason is that they are not what? Like terms. No, me brother. A is different from a square. They are not the same thing. Here we have 5a minus 2a. Can it go? Yes. You get a 5. You come to owe somebody. How many? 2a. When you subtract, what will remain? 3a. I hope this one looks like a. 3a. The same way we move. We say a minus b is equal to a minus what? B. Not like terms. You cannot. That's why it is minus. It remains like that. Here we have 3c minus 5c. What does it mean? You are having 3c and you owe 5c. Okay, if you pay the 3 that you have, you still owe it. Is it not so?
Yes,
Directed
sir.
number. And that's why you have what? Minus
Minus
2c. Take note of that. Open your eyes, study. Y square minus s square. It cannot go, my brothers. So that's why it remains y square minus what? S square. Reason, they are not like terms. Not like terms. But look at this. 3y square minus y square. Y square, is it not so? Yes. You have 3 here minus 1. What will remain? 2y square. If you know this, memorize this. You're on your way. I'm telling you. Multiplication of algebraic this thing. Multiplication. In this case, 2 times a is equal to what? 2a. In algebra. That's a into 2. That's what the meaning. 5 times y is equal to what? 5y. A times a is equal to what? A square, or a raised to power 2. Y square times y raised to power 3, which is cube. So this plus this is equal to what? 5. It means y, and finally y raised to power 5, which means y times y times y times y, 1, 2, 3, 4, times another word, y. That's the meaning. That's the meaning of y raised to power 5. That's the meaning. So here we have 2a times 3a, which is equal to what? 6. 2 times 3 is 6, and also a times a is what? A square. A times b is equal to ab. Say what? Ab. A times b is equal to ab. Take note of that. And here we have ab times b. In this case now, the b will square, meaning that we have 2b. Is it not so? Yes. That's why you are saying b raised to power 2, b square. A, b square. And if you know these things, your expansions and factorization is a simple thing. This is where you concentrate. With your directed numbers, you can solve your expansions, I'm telling you. Look at this. 2b times a. If it is addition, it won't go. It will join together. 2ab. Which means 2 times a times what? B. That's the meaning of that, this one. If you want to express it. This one is 2a square times b is equals to 2a square times 2a square b. The times will go off. The b will join with them. And that is what you have. If you can study this, pay more attention, we will get there. A square times a square is equal to a raised to power what? 4. 2 here, 2 here. Raised to power 4. And then a square times b square, they are not the same. Everybody go there in one. A square, b square. That's all. So that's the final. So here we are. And then let's see what we'll do. The division. Division, in that case, let me put this here. Division. Division of algebra. Look at what will happen. In division, I will show you division. These are the things you must know. If you have a raised to power 3, divide by a raised to power 2. What it means is that a times a all over a times what? A. Can you see them now? Because 3 divided by 2, 2 they under. Cancel a, cancel a, cancel a, cancel a. What is remaining? A all over 1, which is equal to what? A. The only one A now remaining. That's the answer. It's very simple. There's nothing there. That's number 1. Number 2. Number 2, if I say simplify, maybe something like 6x y3 divided by 12y2. It's very simple. What do I mean? I mean 6 times x times y times y times y, because y is how many? 3. Is it clear?
Yes.
All over 12 times y times another what? Y, because y raised to power 2. Can we see that?
Yes.
That is it. So once you can express them like this, you can cancel out. Let's see what we will do. I can say y here 1, y here, y here. I've cancelled out the y's. 1 still remains up because it was 3. Here now, 6 can come here 1. 6 here becomes 1, 2. What do you have? X times y, which is xy all over what? 2. And that's the answer. Number 3. Let me take another one and end it there. I think maybe something like, okay, simplify. They will say like this. Simplify. Simply to analyze and small. Something like 9a square. This is 9. So I'll write like a. 9a square. 9a square b square divided by 12a b cube. Are we there?
Yes.
So, see what I will do now. That thing you are seeing there now, let me simplify it and then so that I will end up this one. It means 9 times a because a 2 times, is it not so?
Yes.
Then times b 2 times, is it not so?
Yes.
All over 12 is here, you put your 12, you say times, this is a, times another word, b, then how many there? 3. Thank you, my neighbor. This is 3. So let's begin to count. B here, B here. B here, B here. 1B is still remaining, is it not so?
Yes.
A here, A here. 1A is still remaining up. Then 9. 3 can come here. 3. 3 here is what? 4. Common factor. 3 can divide here, 3 divide here. I use 3. So in that case, what do I have? 3 times A will be what? 3A. Any other thing remaining up? No. All over 4B. This is the answer. So, as I told you before, this is algebra. And this now we are treating factorization. Factorization is the opposite of removing of brackets. We factorize, put them in factors. But notwithstanding, before we move forward, I will talk about common factor. Common factor. A common factor. So, what do I mean by common factor? As I said before, common factor is what somebody has. Maybe, for instance, if I say common factor of 15 PQ is equal to 3 times 5 times P times Q. We are saying things that can multiply to give us what? 15 PQ. That is common factor. Another one, if I have something like, this is 1, 2. If I have something like 10A S square is equals to maybe 2 times 5, is it clear?
Yes.
Times A times x times another what?
X.
X. That's all. These things when multiply will give us this. So these things are factors of this. Why these ones are factors of this? Is it observed? Yes. But if we want to talk about highest common factors, let me show you how we get our highest common factors, not common factors. For highest common factors, HCF. I've given you the definition before. Highest common factors. Let me go ahead and do it. One hand. Find the highest common factor of AB square and A square B. First of all, what is the factor of A, B square? It is A times B times B. Is it not so?
Yes, sir.
What about the other one? A square B. That one is A times what? B. So we want to consider what they have in common. They have A. Is it not so?
Yes, sir.
They have B. Is it not so?
Yes.
Therefore, the highest common factor HCF of this and this is equal to A and what? B, which is what? AB. A times B, which is equal to AB. That's the highest common factor. AA, BB, they have. So that is that. Then let me give you another example of highest common factor so that we'll move on to another better things. Okay, let's say find the highest common factor of say 15 y3, y raised to power 3, and 5xy squared. Find the HCF. Find the highest common factor of this. 15y cubed and this. First of all, 15y cubed. What is the factor? Is it not 3 times 5? Times y, times y, times what?
Y.
And then 5x squared. Is it not 5 times what? X times what? Y times what? Y. That's all. So let's find. Therefore, the HCF will be, let's take, what is common here? 5. Is it not so? We say 5 times, what again? Y, any other Y? Yes, Y, which is Y times Y. Any other thing there? No. In that case, the HCF is 5y squared. That's the answer. And that's final. We stop here for highest common factors. We stop here for highest common factors. The next thing I will do is removing of what? Brackets. Under factorization, removing of brackets. That is why I told you, you must know your, what do you call it, directed numbers. In case of plus, minus, minus, plus, all those multiplications. And then if you know that, what I told you before about algebra, the multiplication, a times a square, then you have no problems. So this time I will say, remove brackets. Remove brackets. Let's see. Brackets. Okay. Okay. Let us see. Number 1, let's remove brackets. We have 2 into a plus b, and then we say remove brackets. What will be the answer? We want to remove brackets. 2 times a, what is it? 2a plus 2 times b equals to what? 2b. This is the answer. Is it so difficult? It is not, my people. Number 2, and we say again, 2 into a minus 2g, and we want to remove brackets. Let's remove bracket. 2 times a is what? 2a. Is it also? Minus 2 times b, 2 times 2, is it not 4? So 2 times 2g will be what? 4 what? 4g. So this is the answer. Is it difficult? It is not, my people. So number 3. Let's take another one. Let's take something like this. Minus 2 into x plus y. Bracket close. Let's see what we will do. Minus times plus is minus, is it not? Yeah. So 2 times x is what? Minus 2x. Minus times plus is what? Minus. So minus again. 2 times y is what? 2y. So the answer becomes minus 2x minus what? 2y. That is the answer. See, mass, nothing. That is nothing, my brother. That is nothing. Okay, let me give you another, the last one for this group. Last one. Let's take for instance minus 3 into 2a minus b. Let's open the bracket. In this case, minus times plus is minus, is it not so? Yeah. So 2 times 3 is 6, is it not so? Yeah. So 2 times 3a becomes what? Minus, first of all. Let's put this line. Minus 6a. Minus times minus is what? Plus. Remember the directed number. So we put plus. Minus 3 times b will be what? No, 3 times b will be what? 3b. This is the answer. That's all. So here, we are through with remove brackets. The next thing we will enter is factorize the following. To factorize. To factorize, that's all. There are a lot of them. I cannot, my brother, there is no time. I cannot. So all you do in our textbook, this book we are seeing here, all we'll do is just get you involved. Get the books. You will see the exercises after small examples, small one, stage by stage, so that you'll be able to help yourself. They are there, teach yourself. Please. We made it so that it will be very simple. So let us solve. This one is factorization, okay? Factorize the following. So to factorize, let's say number 1. Already we have factorization. Is it not so? So somebody say factorize. So let me go ahead and solve. This is 5p plus 5q is just the same thing. Opposite of what we have done now. We want to put in brackets. So what do they have in common now? What is common factor? 5. So you bring that 5 outside and put bracket. What will remain here? P. Because 5 times P will give you what? 5P. You put plus. What is will remain here now? Q. So 5 times P is 5P. 5 times Q is 5Q. So this is the answer. It's too hard? It is not. So number 2. Let me give you another one. Remove brackets. And I have 3D squared minus D. And we are asked to remove brackets. What do they have in common?
J.
To put brackets, yeah. To factorize. What do you have in common?
D.
My brother. So we bring out D and put bracket. D times what will give us 3D squared? Is it not 3D? Is it not so? Because when this D comes in, it becomes D raised to power what? 2. And then we will say minus. What will be here? 1. D times 1 will give us what? D. So this is the answer. Let me give you another last one before we leave. Number 3. In that case, I want to take this other one. Yes. We have 2a b squared minus 4 a squared b equal to, let's factorize. We have 2 here, we have 4 here. Is it also? What's the common factor? It's 2. It's 2. Is it also? 2. So we can bring out 2. Then a is here, a square is here, so we still have a. Is it also? So if I put my bracket, what will this 2a multiply to give us 2ab squared? So, no, there is b squared here, there is b. So it is not complete. There should be b. I don't know if you understand what I mean. We have b here, we have b here. Although 1 here. So we have 2ab. So if we put bracket, what will this multiply to give us this 2ab squared? That should be ordinary what? B. Because when this multiply, this b will make this one to be 2b raised to power 2. And then 2 times what will give us 4? Is it not 2? You put your 2. And then 1a is already outside. So we need another a inside. Is it not so? And then any other b? No, this b will come here to make it up. So this is the answer. That's that. Yeah. So we are through with that. There is another one I will introduce. Let me solve 2. Factorize by regrouping. By grouping, not regrouping. Grouping in pairs. So I will clean this, and in that case we will factorize by grouping. Grouping in pairs. Factorize by grouping. Factorize by grouping. Are we there? So to factorize by grouping, take for instance number 1. And you have ax plus ay. Are we there?
Yes,
Plus 3bx plus 3by. I want to group. Let me bring these two together. So I will say ax plus ay. And I put bracket. And I come this side. I put, what do you have? 3bx plus 3by. I put another bracket. I'm grouping them now. This group, this group. And what do I do? And then I said, what do they have in common now, my brother? A. You bring A outside. What will remain? X plus Y. Because A will go here, AY. A will come here, A this one. And then here, what do we have?
B.
3b.
3 is common, is it also?
Yes.
3b. B is here, B is here, is it also?
Yes.
So 3b will come out. So plus 3b into, what will go? What will remain here now if we remove 3b? X plus what? Y. And if you watch, x plus y in the bracket, x plus y in the bracket, is it not so?
Yes.
Therefore, we collect outside. Here is a plus 3, we put in bracket. We collect any one of these because if you are solving to know that you are right, these two inside the bracket must be the same. Therefore, we collect one of them, x plus y. If it is expansion, I will expand this thing now. The next thing I will do is expansion. We will see it. I will expand this to get this thing that you are seeing here, life and direct. So let's go number 2. If we have something like b squared minus q QP plus 3P minus 27. Am I correct? I mean, that thing is 9. No, it's not P2. It's 9. It's 9. 9P. Huh? This is 9P. So let us factorize by grouping. What do? We group this one. Is it also? P square minus 9P. We group. We put our plus. We put this one. What do we have? 3P minus what? 27. We want to see what do they have in common here?
It's
P.
P. So P comes out. What will remain here?
2.
P minus 9. Because P times 9 will give you 9P. Is it not so? And then here you say plus. What do they have in common? If we take 3, 3 can go here. Is it not so?
Yes.
So we bring that 3. Then we say what will be here? 3 times P to give us 3P. Is it not so?
Yes.
So minus 3 times 1 will give us 27. 9. 3 times 9 is 27. So what is here must be equal to what is here. So you collect one of them. P plus 3 into bracket into P minus 9. This is the final answer, my brother. And here I close curtain for that, factorizing by grouping in pairs. By grouping in pairs. So I will go into what I call factorizing by regrouping. You regroup on your own. After regrouping, I think we're almost there. So factorize by regrouping. Let me put it like that. Factorize by regrouping. Regrouping the fractions or the algebra, whatever, by regrouping. So let me clean so that we'll start from there. We have number 1. We have xy minus gf minus gy plus xf. If you watch, this one and this one, they have nothing in common. You see also?
Yes.
But instead, cx here. Are you seeing it?
Yes, sir.
So we bring them together. So look at what we do. What we do now is we say xy, we bring in minus g what? gy. Is it clear?
Yes.
Then we say plus xf, we bring down what? Minus gf. Is it clear?
Yes.
Now, in this case, now you cannot say that this one have common thing. So we cannot continue from where the other one.
Yeah.
So it's the same thing. Now we group like this. So all we need to do is xy minus gy. This is g. We put bracket, we put plus, we put. This one will be xf
F.
minus g what?
F.
Gf. Common factor here is y, is it not so?
Yes.
Y will come out. What we have? X minus g.
G.
Is it true?
Yes.
Yes. Plus, what is the common thing here?
F.
F. Thank you, my brother. Then x minus g. Remember I told you what is here must be what is here. So you collect y plus f into x minus g. If you expand this, we are going to get this. Get our workbook. The workbook, I call it workbook. Everything that is on this CD is on that workbook. As you can see, Globavasity Basic Mathematics workbook on DVD VCDs. Get it. You will like it. So we're going to expansion. We're going to what?
Expansion.
I told you before now that mathematics is all about you enter, you come out. If you enter and you cannot come out, my brother, I tell you, you don't stand there. So you must enter. You know how to enter, you know how to come out. In this case, we say expansion under algebra. Expansion. Or expansions, yeah. Because it may not be one. We're expanding them. Now, I will take only 2. Or maybe 3 highest. Take for instance, if you have a plus b, are you there?
Yes,
Into a plus 2. We want to expand. First of all, you must consider 1 to be a multiplier. Let's take this one to be our multiplier. That's why I gave this mark. If this is our multiplier, we'll scatter it. And then we'll put the whole of this one inside. We'll bring that a, this is our multiplier, into a plus B. Are you there?
Yes, sir.
What is remaining here? Plus 2. Is it also?
It is.
You put bracket, still carry this one, put inside. A plus what? B. Did you see what I did? This one remained inside the bracket, this one. This one, multiplier. I may decide to use this one. So as I use this one, I mark it. I bring out the A, I bring out the plus 2. Let us expand. You see what will happen. A times A, what is the answer? A square. You see that thing I was teaching you? Plus. A times B is equal to what? AB. Then 2 times A is plus what? 2A. Then 2 times B is what? 2B. In that case, is there anything that is addable? No. This one cannot add with this. This one cannot add with this. This is the answer. It's not difficult. It is not, my people. It is not. Very simple. Let's do another one again. Let's see. For instance, if I have m minus 6 into m plus 3. Do you see that?
Yes.
Good. As you have this, let's take maybe this side now to be my multiplier. Meaning that is the one I will share. First of all, I will collect m. M will come out. I will put the whole of this. M plus 3. And close my bracket. What is remaining? Minus 6. And then I put my bracket. M plus 3. What is in this bracket? It's just this one. Are you seeing it?
Yes,
Then let us expand now. That's why we say the expansion. M times M is equal to what? M square. M raised to power 2. Then M times 3 plus 3 is what? 3M. Minus 6 times M is equal to minus what? 6M. Minus 6 times 3. Minus times plus. Can you see directed number? Minus times plus is minus. So 6 times 3 is what? 18. Is it clear?
Yes, sir.
Good. In this case, let's see. We have M square, 3M minus 6M. What do you understand? You have 3M, you are owing 6M. If you pay, what will happen? Minus 3M
3M.
minus 18. This is what will remain. If I expand this, I will get this. For this reason, I will stop here for expansion. Okay, simple equation. This is under algebra. We have simple equations. What makes it simple? If you have A is equal to B, this is the bridge. They must equal each other. They must be balanced. If not, your equation is not correct. It's wrong. But when we solve, we will do what is called check. For example, say number 1, if you have A plus 2 is equal to 5. There are many ways we can solve this. Step 1, watch. I solve here, I solve here. Some other person will say, collect like terms. Say, collect like terms. What do I mean? A is equal to 2 will come over to his brother. And then you say 5. For these 2 to cross this bridge, something happens. If it is positive, it changes to what? Negative. Therefore, it becomes minus 2. In that case, A is equal to 5 minus 2 is equal to what? 3. So the answer is 3. Some people will say, no. I don't want it that way. Plus 2 equals to 5. Watch. We have plus 2. So we'll use minus 2 to remove this 2. Is it not so? Therefore, it will be add minus 2 to what? Both sides. In that case, it will be A plus 2 minus 2 equals to 5 minus 2. Can you see it now? Minus 2 minus 2. 2 minus 2 is equals to A. This one has gone. What will remain now is A. Equal to 5 minus 2 is equal to what? 3. Can you see? If you want this way, you can go. If you want this way, you can go. I have to economize because of my time. Then I'll put in another one. Another one will say something like this. Simple equation. For instance, if I say x minus 3 is equal to 6. What do I do? The same thing, collect like terms. Collect like terms. All you do, x is equal to 6 minus crossing over, minus 3 crossing over becomes what? Plus 3. Therefore, x is equals to 6 plus 3 is equal to what? 9. X is equals to 9. In the same way, if you do what I did here before, you will still get the same what? Answer. By putting minus 3 plus 3, we will now add plus 3. And add plus 3 this side, it will go. That's simple. Very, very simple. So please pay attention. There's nothing. Look at these textbooks, as you can see. Everything is detailed bit by bit, from simple to complex. Let me look for another type and bring in and see what we can do. Let's say number 3. Number 3 will say something like 2b is equal to 6. In this case, how do we solve? Somebody will say, okay, divide both sides by 2, because we want to get b alone. So we want to remove these 2. We say, okay, divide. This is where division comes in. Divide both sides by 2. In that case, 2b divided by what? 2 is equals to 6 all over what? 2. So 2 here cancel. What will remain is b equals to 2 divided 6 is equal to what? 3. Do you see the answer? Now, the same answer, if another person wants to work in another way, look at what the person will do. Somebody can say 2b equal to 6. Therefore, to make b, coefficient of b is 2. Therefore, 6 divided by the coefficient of b, which is 2. Therefore, b is equal to 6 divided by 2 is equal to what? 3. This way it will go. Dividing this other side with the coefficient of b, or doing it this way, it will all go. So take note, because I don't have much more time, I would have taken time to do this. And sometimes if you do, there is what I call check. I was supposed to check for you. Let's see if it is true. We are saying that b is equal to 3. So on check, look at what will happen. 2 times 3, because we say b is 3. 2b is 2 times b. Is it 6? Yes. So the answer is correct. That's the check. So what else do I do? Let me see if I can pick some this way. Okay? Say number 4. Number 4, we have something like y all over 15 is equal to 2 all over 3. In case if you have something like this, then it's under simple equation 2. It's part of it. What do you do? My people, what I will tell you is to cross multiply. You do what? Cross multiply. Because of this is equal to this. If you want to cross multiply, this one to this one. So 3 times y will be what? 3y. 15 times 2 is equal to what? 30. Therefore 3y is equal to what? 30. It's equivalent to what you have here. You know, so then somebody can continue the solving. Mathematics is very simple. Very fair, I'm telling you. Because you can solve this, it's finished. Somebody will say y is equals to 30 all over what? The coefficient of y, which is 3, which is equals to y is equal to, what is it? 10. Is it also? But if you don't want to go through this way, somebody can say, okay, see what I will do. From here again, you can have 3y equal to 30. You say, okay, let me divide both sides. Divide both sides by 3. We want to remove this 3 so that we have our y. Therefore, 3y all over 3 is equals to 30 all over what? 3. What does it mean? It means this will cancel this. We now have y equal to what? 30 divided by 3 is equal to what? 10. My brother, that is it. Very simple. No problem. Let me do the last one and we'll leave this area. So as you can see, look at this one again. If we have something like this, 3f, number what now? Is it 4 or 5? 5. Number 5. If we have something like 3f minus 9 equal to 8, and then you want to solve, you collect lightens first. Collection of lightens. Some people writing too much. I don't have that time. Collect like terms. What do you do? You say 3f is equal to, this one comes to the brother. 8 first of all. This one crossing now. Minus 9 crossing will be what? Plus 9. In that case, we say 3f is equal to 9 plus 8. 17. Is it correct? Therefore, f is equal to 17 all over 3. And that's the answer. Nothing more than that. Nothing more, nothing less. You can still solve the other way by making coefficient. By the time you get here, you're making coefficient of x. F is equal to this. Or you divide both sides by coefficient of x. It will go. Okay, let me do the last one. For the benefit of some people that want to talk about binomials. Simple equation involving binomials. Look at what I mean by binomial. Number 6. In this case, we have 3 all over x minus 3 is equal to 2 all over x plus 4. Look at what I will do. In this case, you cross multiply. Cross multiplication. This will go here, this will go here. So it becomes 3 into x plus 4. Because this one will multiply this one. And this one will go like this, equal to 2 into x minus 3. Is it clear?
Yes, sir.
Now watch what will happen. 3 times x is what? 3x. 3 times 4 is 2f. Equal to 2 times x is 2x. 2 times minus 3 is minus 6. Is it also? Now let's collect like terms. Let's bring this one this side. Therefore, the other time somebody will say collect what? Like terms. Let me write before those people will prosecute us. Collect like terms. So in that case, look at what will happen. We will now say 3x. We bring this x. This one is plus. Coming over becomes minus what? 2x. Equal to, already minus 6 is here. 2f plus 2f crossing over becomes minus what? 12. Is it clear?
Yes, sir.
Now let's see. 3x minus 2x. Remember I told you what will remain is what? X. If x remains, minus 6 minus 12, who will tell me the answer? Minus 18. Therefore x is equal to what? Minus 18. That's the answer for that one. In that case, I'll move into a new business. And what is the name of the business? I tell you, it is called algebraic fractions. Algebraic what? Fractions. But there's something you people will do for me. What does that mean? What is it? In this case, I may not spend time doing so much LCM before. There's no way you will do fraction without talking about LCM. Is it also? LCM was coming, but I will touch it briefly so that we'll move on. We'll talk about algebraic fractions. So, in this algebraic fractions, see what happens. First of all, I talk about algebraic what? LC what? M. And I told you that LCM means lowest common what? Multiple. Lowest common multiple. So in that case, see what will happen. If I say find the LCM of, what is it? What is it? LCM of a square and the b. Are you with me? Now see what to do. You know our pattern of LCM now? A square and what? B. So you say A will come. If A come here, how many A will remain? 1. B will come down. A will do what? Come again. 1 here. B will come. Is it not so? So what will go now? B. B here, 1, 1. You never finish. You don't finish. Therefore, LCM of that term will be A times what? B, which is A square B. That's the answer. I will do another one for the benefit of doubt. And then. This is number 1. Let's say number 2. Number 2, and somebody says, find the LCM of A square B and AB square. LCM. Find. Say find. Okay? LCM of this number here. What do we do? See what we will do. If I'm going to do something now, I will draw. I will say A square B into AB square. and then I will put my A. A will come, A will remain here. B, is it not so?
Yes.
This A will cancel this A. What will remain is B raised to power 2. A will still go again. A here, what will remain is B. Here is B squared. In that case, B will go again. This B will go. 1B will remain. B will go again. 1, 1. You never finish. You don't finish. In that case, LCM of this animal will be A times B times B, which is equal to A square B what? B squared. My brothers. I ended up there. So take note of that, my people. Take note of that. If you do so, look at what I will show you now. I have something here. In case somebody gives you, find the LCM of, say for instance, binomial, where you say A plus 2 and A minus 3, something of this nature. How do you find the LCM of this and this? The LCM simply means LCM of that is equal to A plus 2 into A minus 3. This and this, that's LCM. That's all. So, with knowledge of this LCM, we can now solve algebraic what? Fractions. Algebraic what? Fraction. Remember, you can only solve algebraic fractions when you know how to handle your algebras. You know how to find your LCMs, the problems are over. Very simple. All you do, get the CD, get this textbook. The textbook is teach yourself. The CD, once you watch the CD, you can handle it. We made it very simple, from simple to complex. So, algebraic fraction, let's try number 1. This is the fraction, 2 all over A plus 3 all over B. Who will tell me the LCM of A and B? It is AB. It is what? AB. If you want to find it, you do it with that method. You will get it. So, here, the LCM of this is what? AB. If A comes here, what will remain? B. Is it not so? Yes. If A comes, A will cancel this A. What will remain is B. B times 2 is what? 2B. You put plus. If B comes here, what will remain? A. A times 3 is what? 3A. What do you have? 2B plus 3A equals to, this is the answer. You know, it's very short, very simple. No why you. No why you. So look at another one, number 2. 3 all over 2B minus 5 all over 3A. What is the LCM of 2B, 3A? 2 and 3 is 6, is it not so? So LCM becomes 6A. A is a, no, is it B? Yes, 6AB. So if 2B comes in, 2 here, it will be 3, is it not so? B will go, it will be 3A will remain. 3A times 3, which is 9A, put minus. And then 3A here, A will go, B will remain. It becomes 2B. 2B times 5 is 10B. 10B. They cannot subtract, they cannot add. This is the answer. But if I leave this answer here, this is 9, I think. Yes, this is 9, not small number. This is 9. So that we don't... if this is 9, this is 10. They don't have any common factor today, nothing. So this is the final answer. Let me pick another one. Let me pick another one, number 3. And I have 1 all over AB minus 3 all over B squared. You know the LCM? Can somebody try? The LCM of AB, B squared is
AB squared.
Thank you, my brother. AB squared. The highest B is B squared. A is only 1. It's very simple. If you know this thing, this logic, there's nothing. You don't need to think about anything. So if A becomes here, what will remain is 1B. Is it not so?
It is.
So 1B, B times 1 is B. You put minus. If B square comes here, what will remain is what? A. A times 3 is what? 3A. Therefore, this becomes the final answer. Some people they suffer from maths. There is nothing. Change. So let me give you another one. Number 4. Number 4, let's take something on a different style. This all over 5, minus y minus 1, bracket, all over 2. My people, watch and see what I will do now. So, it will happen. It's very simple. What is the LCM of 2 and this? Is it not 10? It is 10. Abi? 10. 5 into 10 is not 2, is 2. Then we'll say 2 into y minus 3. It says I can write down. I don't want to multiply yet. And then I put my minus sign, this minus sign here. If 2 comes to 10, what will remain? 5.
5.
Then I'll put 5 into the whole of this because I want to use that 5 to multiply what is in that bracket. With this now, mass don't set, it don't finish. All I need to do is to say equal to 2 times y is what? 2y. 2 times minus 3 is minus 6. Minus 5 times y is minus 5 y. Minus times minus is plus. Minus 5 times minus 1 is plus 5. Is it clear?
Yes,
All over 10. Collect right hands. What is the right hands? Bring them together. You may decide to do it this way. Equal to 2y minus 5y plus 5 minus 6. That is what we have here. Is it also?
Yes.
Then let's add together. All over 10. 2y minus 5y. What is the answer?
3y.
Minus 3y. Then plus 5 minus 6 minus 1. Is it also?
Yeah.
All over 10. And that is the final answer. That is it. Yeah, that's the answer. Okay, let me give you another thing. Why I'm solving all these things so that in your book, when you have the book, you can easily work. What do I mean by work? There's no example that you will not see, that you say I did not say anything about it. So that you know what to do. Divide by 40 all over 9. 9. So, I told you something about division. 2b all over 3. This division, you change it to what? Multiplication. And turn over this. Is it also? 9. This is 9. All over 40. Is it clear?
Yeah.
Good. Which is equal to? You can cancel. 3 here, 1. 3 here is what? 3. Up times. You can say, okay, I don't want to cancel. If I want to cancel, 2 here, 1. 2 here, 2. But let me do it this way. 3 times 2 times 3, 6. 6b all over 4 what? T. If you leave this answer like this, you have failed. Because you need to reduce to the lowest term. What do you do? 2 can go. 2 here is 3b. And 2 here is what? 2t. This is the final nomenclature. Here you can see, I said, special subjects. There are areas I want us to look at again. Let us solve. 3 times 2, no, 3 times 6, 18. 18 plus 2, 20 all over 3. Minus 4 times 5, 20. 21 all over what? 4. And we said, what's the LCM of 4 and 3? It is 12. Is it not so? It is. In that case, 3 comes here. 3 divides 2, I will give you what? 4. 4 times 20 is 80. Minus 4 into 12. 3. 3 times 21. 63. 80 minus 63. 17. All over what? 12. In that case, how many 12s are here? It's one whole number. 5. I mean, is it 5? Yeah. 5 over what? 12. So this is the answer. The final answer. Let's say we have 4 all over 5 of 1 over 2 plus 3 over 4. Maybe 1 over 1 all over 3. Something like this. And somebody said solve. Some persons, when they see something like this, they won't know what to do again. It's very simple. Take it bit by bit. Remember our board mass. Board mass. Bracket off. So we start with brackets. So we say 1 over 2 plus 3 all over 4 which is the LCM of 2 and 4 is what? 4. 2 into 4 will be how many? What?
2.
2. 2 times 1 is what? 2. Plus 4 into 4 is what? 1. 1 times 3 is what? 3. Finally, we have 5 all over what? 4. That's what we should have here. In that case, it means we are saying 4 all over 5 of 5 all over what? 4. You see also? Good. All over 1 all over 3. Can't you see? It can be reduced. We have settled the bracket. So we move further again. We want to solve off. Bracket off. Is it also? So we take it again. 4 all over 5 times. And remember I told you off means multiplication. 5 all over 4. Jesus Christ of Nazareth. This is blunder. Here 1, here 1, here 1, here 1. Or you can say 5 times 4, 20. 4 times 5, 20. 20 over 20 is equal to what? 1. So what we are having here is equal to what? 1. The whole of this up is 1. Therefore, our answer is 1 divided by 1 all over 3. You see this big division? Some people may not understand what this thing means. Let me rearrange it. It means 1 all over 1 divided by 1 all over what? 3. That's the meaning. If you don't do it this way, you may not understand, and some people will fail from here. What it means now is that 1 all over 1, you now change this to multiplication times, this one goes up. 3 all over what? 1. In that case, what happens? 1 times 3 is 3. 1 times 1 is 1. 3 over 1, this divided is equal to what? 3. The whole of this big mathematics. The answer is what? 3. Simplify 6 d square f all over 8f. It's very simple. Somebody see this one and say, don't see math. That's no math. What it means is 6 times d times d. Is it also? Yes. Times what? F. All over 8 times f. Cancel f, cancel f. In that case, no d will remain. Something can go 2. 2 here, 3. 2 here, 4. You see also? So what we have is 3d squared all over 4. That's the final answer. It's not difficult. Very simple. Let's find some HCF first before we move further. Say for instance, find the HCF of let's see 3x squared and 9xy. In this case now, there is number, there is what? Algebra, letters. So what it will be, you say 3x2 into 9xy. You put like this. Watch you, very simple. Let's start with the numbers. What will go? 2 cannot go here, is it not so? 2 cannot go, so we say 3. 3 here is 1. No. 3 will go. What will remain is x squared. 3 here is 3. Is it not so? With xy. 3 will go again. What will be? X squared. What will remain here? xy. 3 is gone. Is it not so? This 3 will cancel this 3. In that case now, numbers are finished. We talk about what is remaining, x. X here, 1x will remain. This x has gone. What is remaining is y. And the x will go again. X has finished. Y will go. So y will go 1, 1. It never finished, it's finished. Therefore, HCF of this and this is equal to 3 times x times x times y, which is equal to 3 times 3 is what? 9. X times x squared y. Is it clear?
Yes, sir.
It's very simple. 2xy minus 5x plus 2y minus 5. My brother, we factorize by grouping in pairs. So what we do, we group these two. 2xy minus 5x cross, what you have is 2y minus 5. Is it not so? We are looking at what will happen now. Very simple, very, very simple. See it. You will discover that here, what do they have in common? X. X will come out. That's the only thing they have in common. What will remain? 2y minus 5. Is it not so? And that's exactly what is here. So what we do, we say plus 1. Because 1, anything multiplied by 1 will remain that thing. Is it not so? Therefore we put 2y minus 5. Are you seeing it? So 1 will multiply it to remain the same thing. In that case, what is here is what is here. So we take x plus 1 into 2y minus what? 5. And this is the final answer. Let's do something like this. 5 all over p plus 3. Assume you have something like this and somebody says solve. Evaluate is equal to 2 all over p minus 4. Are you with me?
Yes, sir.
So what you do is to cross multiply. So this to this becomes 5 into p minus 4. You put your equal sign. This one will come. Put the 2, multiplying this, you put bracket p plus 3. So in this case, let's open the bracket. 5 times p is what? 5p. 5 times 4 is minus 20. Equal to 2 times p is what? 2p. 2 times 3 is what? Plus 6. Now in this case, we don't even want to write too much. We can say collect what? Like times. But I don't want to write too much now. There's no much time. All I will do is to collect like times. So I will say this one will come over. 5p minus, because this one is plus here and I'm coming over to become minus 2p. Is it not so? Equal to plus 6. This one is minus. Crossing over becomes what? Plus 20. Remember, that's the law. Whenever something is negative, crossing the other side becomes positive. If it is positive, crossing becomes negative. So 5p minus this becomes 3p. Equal to this plus this is what? 20 what? 6. 26. In that case, p is equal to what? You don't see? Let me see. So that I want to shift this way. Then I will say, in some cases, if I want to write, I will say divide both sides by 3 because I want to remove this 3, the coefficient of p. But if I don't want to do so, I will just say p is equal to 26 divided by 3. Can 3 divide 26? Listen, 3 times 7, 21. 3 times 8, 24. Therefore, 8 whole number 24. 2 all over what? 3. That is the value of